Hey, Pure, how's it going? Good to see you. It's going. Keep your chin up, Pure. Keep your chin up. This too shall pass. Just getting set up here. um, this okay. Let's look at the Twitch ads out of the way. Okay. Welcome, everyone. Hope you're all doing all right today. You streamed for a minute, Pure? No way. Hey, Ray on YouTube. Yeah, you switched to Linux full time. Never felt better. That's good, man. That's good. Welcome to the club. That's what I like to hear. Okay, I think I pretty much have everything I need to get started, I think. So, yeah, good morning, good evening, good afternoon, good day, good night, whatever, wherever. So, I am going to be talking about the state of software because it is in bad shape. I have been doing a series of videos and streams about this. I'm gonna wait for um ads on the Twitch side to be over. It's only a minute, but yeah, this is the I think I'm set up for the main event. Hey, Car on YouTube, remember the 300? I remember the 300. I'm Spartan. What's up, everyone on TikTok? Thanks for the likes. I appreciate it. And the shares. Thanks for the likes and the shares. Not me with the H1Bs? Sure. Okay. 10 more seconds and then we'll get started here. Let me let me get my talking voice going here. I have Array on YouTube. I've got a monitor in my laptop screen. Okay. Listen, folks. I've been wow, I went to clear my throat and it didn't even work. Let's try this again. I have been ranting about the state of software and tech, and just in general, for about a year and some months now, on live streams and videos. You can see them all on YouTube. The live streams are still up there, and I tackle why I think software is in a bad place. One of the things that I've been doing is going through scientific articles that actually demonstrate some of the issues that we have. The reason why this bothers me so much is because I feel like, well, not feel, I know that we leave a lot on the table in terms of our capabilities with what we can do with software and web. And we take it for granted that that we have so much hardware available to us and that we have all the tools that we do. And so recently, there has been some discussion around the H-1B visa program in the US. Now, I'm a Canadian, so I don't have a dog in this fight, but my entire argument is that it's a non-starter. And I went over that. I was on Eric Weinstein's X Space the other day, and I took a shot explaining that. He kind of didn't agree with me at first, and then he agreed with me, and then he said exactly what I've been saying for a long time. So the entire position that I have is, it doesn't matter how many visa programs you bring in or open up. We have to fix what's wrong with the industry itself. And that's a tall order. I realize that. It's like, how are you going to fix everything? There's no way you're going to make it perfect. No, of course you're not going to make it perfect. But I think it's good for somebody, and there are others like me, to point out the issues. Maybe they get fixed, maybe they don't, but it's better to talk about the issues and different perspectives on those issues than to not talk about them. And that's what I've been doing. So this will probably be one of the last ones that I do for a while, because I have to go and spend probably another 2 or 3 months again digging up research on the entire topic. But I have managed to pull a few things together that I can go over. So that said, let me make sure my camera is set up. It is. Okay, so we're going to switch over to this guy. Like so. All right. So this is a good article from Ryan Fleury. And he's brought up something that I've thought about in the past, but never really like mentioned, I guess. Let me get the go. So we have these tools that we build for ourselves as programmers, right? We have the ability to kind of like enable ourselves to create the things that help us to create things. So in this case, you could think of it like IDEs, right? So if you're going to use a development environment, who builds the development environment? Well, that's going to be another programmer. And the intent behind that is to enable you as another programmer to create more code for somebody downstream, ideally like a user. And what Ryan kind of touches on here is that we are our own users. And there is a cost that begins with, let's say, inefficient or poor code, or somewhere along those lines. It begins with us. We're actually kind of shooting ourselves in the foot, so to speak. So I'm going to read this. I usually just pick an article or two to read to open things up, and then I'm going to go into a few papers, just to kind of touch on a few different points as to issues that people do not seem to want to address. At least not the majority. The industry as a whole just seems quite happy with the status quo, for what I think are obvious reasons. So we'll get into it. Programmers are users. Bad performance makes everyone less efficient. On the often referenced notion of saving programmer cycles at the expense of CPU cycles. So right away, you can see that Ryan is talking about something very much in line with what I've been talking about, which is we're trying to save programmer cycles. That is, like, how much effort a programmer has to go through to accomplish the thing. And we do so because it's easy to say, well, even if it costs more in terms of CPU cycles, it's an acceptable cost because you save on the programmer cycles. So let's get into it. And of course, he begins with Bob Martin, which is not controversial at all. No controversy there. I want the act of programming to be easier, more pleasant, and more productive for the vast majority of programmers, and I am willing to sacrifice performance in order to achieve that. This is probably this is probably one of the most short-sighted views I can think of having on just about anything. Happiness on the job and pleasantness and all of that definitely helps. Okay. It's not like there's zero value in this, but let me try this from a different angle. We have gone way too far into the sacrifice performance. How about that? How about my argument is we've sacrificed too much performance to make programmers happy? How about that? There's a pervasive idea in the software industry that's often posed to defend abstractions and software layers, which are easily and often used to generate tremendous amounts of bad code in favor of programmer efficiency in generating that bad code. When I say bad code, I don't refer to what the programmer sees in his text editor. I'm talking about the actual code, that is, what the user's CPU executes. And so right away, we're touching on indirection or abstraction or obfuscation. So the code that is being executed on the CPU is not necessarily the code you're writing, but a lot of people don't know how to do that translation layer, myself included in many cases. I'm trying to learn it, but many people don't even. The argument goes, given these abstractions or layers, maybe they're language features or programming paradigms, programmers can be more efficient in generating bad code, which accomplishes the same meaningful work as the alternative case. Now, I think you could actually substitute bad code in this argument for just any code. It doesn't have to be bad. Any code, abstraction layers or whatever paradigms that can generate any code which accomplishes the same as meaningful work in other code, right? But in this case, I think he and I would agree on what bad code means. Where the programmer does not use these abstractions or layers and perhaps produces good code, but was more inefficient in doing so. The claim, the hypothesis, or as it is often used, the assertion, it is an assertion, is that these paradigms, abstractions, languages, language features, and so on, are more efficient from a business perspective, at the expense of efficiency from a software quality perspective. And a business perspective could be anything like we accomplished, we created and released certain features. We I don't know. We fixed some bugs. Even that could be business value in some cases. But business perspective can mean a lot of different things. But it's usually man, I'm sorry, my throat. One sec. Business perspective is usually put in place of like over top of technical debt. So you're unlikely to tackle technical debt before you're going to tackle whatever the business perspective is on value. And so there's a software quality aspect that gets diminished because the business perspective takes precedence. I recently saw this argument manifest in practice, when I finally watched Ginger Bill's video breakdown of the written discussion between Casey Muratori and Robert Uncle Bob Martin on the technical merits of clean code. It's important to understand that clean code doesn't refer to clean code. Capital C clean describes code in the same way that Democratic People's Republic describes North Korea. It is a label. It has as much information content as a person's name. Bill correctly identifies this and says that it'd really be more appropriately be called Mr. Martin style. And I agree. It doesn't really have much meaning behind besides just being a label. In the video, which I recommend watching, Bill mostly doesn't focus on the technical side of the discussion, and with good reason. As Bill demonstrates, Robert Martin didn't focus on the technical side of the discussion either. Mr. Martin instead opted to debate rhetorically. It's rhetoric, but rhetorically maybe. Bill correctly likens this to being akin to a form of political maneuvering because that's exactly what it is. And here's why it's rhetorical. It is rhetorical because these kinds of assertions that a paradigm, library, language, framework, or whatever that makes programmers feel good about what they're doing, cohesion and synergy and synchronicity and all that stuff, it's based on feelings, and that is rhetoric. Rhetoric its purpose is primarily to make you feel, not make you use your brain in a logical sense. So it is absolutely rhetoric. Throughout the debate, no technical questions are satisfyingly answered by Mr. Martin. If that is what you're looking for, you'll be disappointed. It isn't named clean, rather than Mr. Martin style by accident. I'm going to let the stupid sirens pass. Hey, Laugh, how are you doing? This convenient word choice is often used by clean code proponents to mask unfalsifiable assertions in order to justify certain clean code guidelines by subtly shifting between clean and clean throughout a discussion. Casey and Bill both did an excellent job, but in both the written discussion and the video breakdown, I kept having a recurring thought that I didn't see directly expressed by anyone, and that's why I'm writing this post. You could spend several careers researching programmer productivity. The interface of programming is, of course, tightly intertwined with programmer psychology, the programmer's ability to reason, and the programmer's ability to easily express computational effects. Not all interfaces are equally efficient for programmers to use. Not all interfaces can have equally efficient implementations. Barely investigating this subject leads to the conclusion that some interfaces are simultaneously better for the programmer and better for the CPU than others. Programmer efficiency and CPU efficiency are not always mutually exclusive. One does not necessarily need to always pick one. Unfortunately, serious investigations of these topics are seemingly never carried out by clean code proponents. Claims of improved programmer efficiency at the expense of CPU efficiency are mere assertions. And it's not, see, clean code buckets inside of it a number of other things, including things like React, for example. It could fall under this premise. Other languages like Rust might also fall under this bucket of the assertion that if you spend enough CPU cycles, you'll get better programmer efficiency. But in this post, I want to zoom out from those investigations. I want to give clean coders the benefit of the doubt. Let's say that we are operating in a space where we must trade CPU productivity for programmer productivity. Let's say that we even have tools which we know trade CPU productivity for programmer productivity. Never mind the fact that these premises are never proven to hold. Let's say we find a case where they do hold. I'd like to explain why, in that context, it still doesn't make sense to overwhelmingly prefer the comfort and generative productivity of the programmer writing the code. Even when I've given clean coders everything they could possibly ask for, everything they attempt to assert, there is still a strong argument in favor of software performance at the expense of initial programmer performance. Part of this argument has to do with the overall quality of the computing system, but it is not strictly altruistic. There is also a strong business case for software performance, even with heightened upfront programming cost. I mean, he's basically saying all the things I've been saying since I started streaming. As such, this argument does not require that you have business inclinations, nor altruistic inclinations. You could love or hate the concept of a free market with private property. In all such cases, this argument still applies. Casey did say that in one of his videos. Yeah. The fundamental mistake I see as responsible for entirely destabilizing the argument in favor of programmer code writing efficiency at the expense of software efficiency is an incorrect model of the software ecosystem. Programmers run their own code. The implicit model being used to justify the trade-off assumes a single software producer which produces the code and a single customer which executes the code. So here you go. You have someone who produces some code, it then gets shipped out, and then the user runs that code. But this model ignores the everyday reality of programming. The reality is that the producer must also execute the code as they develop, debug, and test it. Only after they're done that process, only after they've done that process innumerable times, they will submit the software to the user to be executed. And so this is the reality, because you're writing your code and then you're testing it and rewriting it and, fiddling around with it until you get it right. Then you release it. And if you have stages before your release, there could be many steps here instead of just the one, right? So you might be testing it again on a pre-production staging site, development site, whatever it is, running it over and over again, and then you pass it off to the client, who then runs it over and over again, and rinse and repeat. Already in this model, bad software execution time has already caused a slowdown in programmers' productivity. Some amount of the programmer's efficiency in reading or writing the code has already been counterbalanced by the software's inefficiency, because the programmer is blocked on executing his own software. The slow software execution time has thus had an impact on the programmer's iteration cycle time. Mr. Elfman on Twitch, I'm dealing with this right now. I have to wait 2 minutes for something to link. Right. And so this is the problem that comes with utterly contemptible, disgusting, putrid shit like React, where compiling your front end breaks the entire cycle of what we've had that's worked so fantastically well for such a long time, which is you make a change, you hit refresh, there's your change. And even a programmer efficiency in terms of reading or writing the code can still be overcome in a space where it's not so easy to read or write the code. When you're adding complexity and layers and abstractions over that, what you're doing is you're all you're doing is kicking the can down the road. You're actually not solving anything. It's exactly the same argument as, well, I am too intimidated to use CSS, so I'm going to use Tailwind. So in order for you to write CSS, you're just kicking the can down the road. You're going to bring in JS and a build system, and then you're going to write CSS. To continue justifying the choice to prefer programming methodologies which promote fast generation of bad code, one must prove that this degradation of programmer iteration cycle time does not outweigh the improvement in programmer efficiency in generating the code. Given that code can often be written once, but tested, debugged, and tweaked hundreds if not thousands of times, this fact is important to demonstrate, but it is never demonstrated. This is more low level than React. It's a WASM linker. Oh, I see, Mr. Elfman. Yeah. But having a build step makes me feel like a real programmer. Right. And I think this is one of the things that I don't think front end people will admit. But I think deep down inside, they know this is true. Doing something like compiling your front end is just a way for front end programmers to feel cool as the kids they looked up to who were back end programmers who did all the cool stuff on embedded devices and Linux servers. They would look over there. I remember you look over at the people doing the back end, you'd be like, whoa, they really know their stuff. I'm just over here moving pixels around. It's like, well, how are we going to make ourselves look as good as they are? Compile your front end. I mean, I think we just have a lot of poorly made tools. Yeah, Hyla, we do. By the way, hi Hyla. Hi, Mr. Elfman. How are you doing? We would probably solve a lot of this problem if web devs admitted they weren't real devs. Yeah, I think that would be good. I mean, maybe not. Maybe they are. Yeah, we're the jokesies, okay, but I do think that they do. There is a sense of we feel good because of the complexity we have to tackle on the front end. Right? It makes us feel good. It makes us we can compare ourselves to the people who have had to deal with that complexity on the back end or in other systems that we couldn't understand because we're front end people, right? There's something about web dev or web adjacent programmers like my ordinary linker works fine. I don't know, man. I think it's bizarre to introduce a build step to something that doesn't need one, like a preprocessor for Lua or something. Save and run is instant. It's so good. Yes, I don't think you need. You should be asking yourself, why do you need a build step? How far have you strayed from you used to just be able to just change code and hit refresh and you're done to now you have to go through X number, N number of steps to compile your code? Why? I think if you are honest with the answers, the reason why does not always hold weight. If you really need a preprocessor, maybe you're using the wrong language, possibly. Yes. Okay, customers are programmers. But this problem gets worse. Who is the software producer? What are they making? Who is the software consumer? What are they using the software for? It seems like clean code arguments are often made assuming a very narrow definition of these two entities. For example, as used in the original written discussion, some payroll software used by a business to pay employees. But what is the common reality in the software world? Let's take an example from the real world, from my own life, in fact. I work on a debugger project full-time, the RAD debugger. As part of my work on that project, I need to use a file explorer. The Microsoft Windows built-in file explorer is a flaming pile of shit. It's an incredibly poor quality experience for a large number of reasons, probably related to clean code, in fact, which is why I'm excited for my friend. I'm not going to pronounce that because I'm going to butcher it. I apologize. A file explorer project, file pilot. He is a programmer too, and so as part of his file explorer project work, he needs to use a debugger. Hang on, what's going on? You should RadDB to let the audience understand how cool RadDB. I'll do it after. Yeah. Hey Travis, how's it going, man? Good to see you. The dingus has landed. If you're precompiling something like Lua to VM machine code, the reason is going to be performance, skipping the interpretation step, as well as presumably that code being a smaller package, so better content size management, which are all things we talk about around here. Fair point. Fair point, Arvis. Okay, fair point. I guess if I would have to then restate the argument as why do you need to introduce a build step in the world of web development that you didn't really need? Like, you should be asking yourself, do you need it there? Good luck debugging your Lua build step when it breaks horribly. Okay, I'll let you guys go at it. I'm going to keep going. Instead of some arbitrary payroll software producer and some arbitrary business, let's say the entity on the left is me writing the debugger, and the entity on the right is, oh man, I'm going to have to pronounce it, Vyacheslav, writing his file explorer. This is a slight extension of the initial oversimplified model. It demonstrates one simple case of cyclical dependencies within the software ecosystem. This is an overwhelmingly common relationship. It regularly manifests within a single company or organization, but it extends beyond those boundaries as well. So this includes scaling up, right? So we can take into account what happens when you have a large team size. So now what happens is you have the debugger over here, and Ryan has to waste time on CPU inefficient cycles to get the debugger to work. Then the debugger is used by Vyacheslav, who also has to use the debugger in order to figure out what's going on with the produced code. So now you've got this like stack, like, you know, it's growing almost quite fast. The number of CPU cycles wasted. The idea that this is ultimately faster than, yeah, because the way that you read and write code is more efficient, already to me sounds like a steaming pile of bullshit. Hey, Mystified. In this context, if my software is unnecessarily slow, not only does it slow myself down before I release it, it also slows Vyacheslav down in his development. This degradation in his programming performance manifests in fewer iteration cycles for his software, which I also depend on. Because I began by making my software worse than it could have been, that effect has propagated outward into the computing ecosystem. And because the computing ecosystem is a cyclical graph of dependencies, that effect propagates back to me. And now I want you to think about what this means in an ecosystem where you're using a library like, it could be React, it could be Vue, could be maybe Svelte, where you have interdependencies. You cannot use the library by itself. The library necessitates that you import other libraries. So it's like the NPM thing or Rust crate thing, things like this. What happens when you introduce other external inefficiencies that other people have built? And then your argument at the end of the day is, well, I'm wasting a bunch of CPU cycles, but my code for me feels much easier to manage. I don't even know how you could quantify such a thing. Nor do I think that if you did quantify it, the proof would bear out that you're saving time. I think the proof would bear out that you're wasting time. Slowness propagates, then compounds. And not just slowness, by the way. I would add also security vulnerabilities and other issues. But this problem is worse still than I've described. A more detailed graph of the software ecosystem is more complex than the earlier examples. The software ecosystem is a vast, cyclic network of interdependent entities producing software and relying on other software. You can even think about, if you're deploying something to the web, for example, you can even think about the software that runs on the hardware upon which the website is being served from, right? Like every individual point of the life cycle of anything you're producing suffers from this problem. Poor performance introduced at points in this network propagate outwards, because depending on software means executing that software. Execution time of an entity's dependency is, one way or another, factored into the production of the dependent itself. This may be literally execution time in the dependent software, if it relies on a poorly constructed library, or it may be in programming resources if the programmer relies on a poorly constructed tool. Whether it blocks the programmer or the software, it has a cost. The longer the dependency chain becomes, the more likely these effects will be multiplied or otherwise duplicated, and the more likely that these effects will back propagate to the dependent software. Not to mention that the longer this dependency chain becomes, the less likely that anyone will understand what the problem truly is or how to fix it. And this is another key point, which is, again, you're kicking another can down the road. You might upfront, I've been saying this for like the longest time. I have been in rooms where the company has hired React developers who have either like started learning React or are very good in React. And it doesn't happen often. I got to be honest. It happens once in a while. But I can think of at least 2 occasions where the team hit a wall with React on a project we were doing. React could not do the thing we needed it to do for a website. Hey, Sid on YouTube. How's it going, man? Good to see you. Thanks for being here, man. And you're looking around at a room full of React developers who they generally understand React. And so you're, I remember an executive came in because one of the clients was screaming at us, and the executive came in and he's like, so what are we going to do about this problem? What's going on? Of course, he doesn't understand the technical jargon. So there's some back and forth. And then essentially it boiled down to, well, we don't think React can do the thing we need it to do. And myself and one other person, we were like the graybeards and at the time. And I was pretty young, so it's kind of sad that we were the graybeards. We had to go and dig into the React source code to figure out where exactly the problem was and fix it with an escape hatch using vanilla JavaScript. And so this is the problem with the dependency chain, where I think someone said it in chat, Hilo Blocks, React has 97 dependencies, right? This isn't just React. This could be many other libraries, languages, frameworks that have this dependency chain. You're paying a cost in terms of execution time because you don't know how performant it is. The abstractions, the paradigms, the obfuscations necessarily mean that you're highly likely to be less performant. And when an actual problem arises, that problem is much bigger due to the dependency chain than without it. The likelihood of that is high. You're even if you want to take like a conservative approach to this, maybe a more charitable approach, and go, well, it doesn't always mean this. Okay, but how high are you increasing the likelihood that those things are going to like completely block you from moving forward? And what have you actually saved? And so this is what it actually looks like. I'm going to zoom out a little bit. I mean, I could basically just like write npm, or webpack, or import modules or whatever on the web, or compilation steps with React Native. Who knows how many dependencies that you're obfuscating, running a React Native mobile app. Same with React Server Components. What else could you say? Node, on the back end, it's Node could do this too. You npm install with Node or Bun. How many dependencies do you have when you're running Bun? Python. How many dependencies do you have in Python? All of these things have a cost. And the question is, how do you identify the cost of the poor execution, the security vulnerabilities, the issues that come up, the fact that you don't understand what those issues are because you don't actually understand the things you've pulled in, etc., versus the quote unquote benefit of, well, I get to read it and use it easier. It makes me feel good. This reality has explanatory power in describing the state of modern software. Despite vast improvements in computing hardware capabilities, some software often performs dramatically worse than its contemporary equivalent running several decades ago on hardware that was sometimes 1,000 times slower with 1,000 times fewer resources. This is because poor performance in this network does not stop at one edge in the network, it is multiplied several times over. You are amplifying the effects of shit. During the initial discussion, Mr. Martin introduced several time domains. He described some problems as being within the nanoseconds domain, where wasting nanoseconds matters. He described the microseconds domain, where wasting microseconds matters. He described the milliseconds domain, where wasting milliseconds matters. The problem is, however, that there is only one time domain in reality. And wasted nanoseconds add up to wasted microseconds. And those add up to wasted milliseconds. And those add up to wasted seconds. This can happen before network effects in the software ecosystem are considered, simply within one piece of software. And what's interesting, Chris Griffin, another streamer, he put out a tweet or a post on LinkedIn or something earlier today, and he said something along the lines of, I don't understand why people feel like have kind of like a rosy view of developers in the past. Think about Y2K. Those programmers in the 70s and 80s were so lazy, they were trying to save a couple of bytes, and then it caused the Y2K issue because you didn't have enough space to fill in the time. So when 1999 rolls around and those bytes, are now, well, biting you in the ass. Here's the problem. What Chris doesn't get, and what many people don't get, is that these look like small things when you look at them in a small way. But 10 million single bytes is 10 million bytes. 100 million nanoseconds is not just one nanosecond after the other. It's 100 million nanoseconds, which you can scale up to microseconds and milliseconds. I'm not going to do the math in my head. Okay, so these have a cost. And to say, oh, it's just a nanosecond, who cares? It's just like 100 milliseconds, who cares? No, everyone cares, including you. And it scales up in this context, the bigger your team size is. The more users you have. These things scale up. It matters. That's a bad take. Those optimizations were required back then because of resource limitations. They weren't lazy. Devs now are lazy. Correct. I think Chris is absolutely dead wrong about that. That's a pretty brain dead take. It's just a brain dead take. Today we have the space because hardware has improved. In the 70s and 80s, that hardware did not exist. It was a limitation of resources, not because these people were lazy. But even still, the point is saving a couple of bytes is not just a couple of bytes in a vacuum. You can't look at it that way. A couple of bytes multiplied by usages scales up exactly like this argument, right? After network effects are considered, it is perhaps no surprise that programs now accomplish in 30 seconds what they used to accomplish in less than a second on hardware which was thousands of times less capable. Spending software efficiency to obtain programmer efficiency may seem like an appealing idea, but I hope this post helped clarify why it isn't that simple. The acceptance of software production methodologies, like the one Mr. Martin himself promotes, are in part responsible for a vast degradation of software quality and, ironically enough, decreases in programmer efficiency. I open this post with a quote from Mr. Martin himself. I want the act of programming to be easier, more pleasant, and more productive for the vast majority of programmers. Unfortunately, the act of programming is harder, less pleasant, and less productive than ever because of systemic excuse making for mediocrity. Sacrificing software efficiency for programmer efficiency seems to simply result in losing both. Yeah, no one's happy. Not even the people who are using the things. That's right. Okay. So I'm gonna here, I'll put chat up. I'm gonna set up the next article here. Maybe let me do the ads, get them out of the way. So the next one I want to do um not this one, not that one, not that one, not that one. Nope. Okay, so the Python one, and let's go with where's the TypeScript one? The TypeScript one. Okay, we'll do that. We'll do those two. I'll wait for the ads to be over and then we'll go over it. So I'll just talk while the ads are going. So I mean, already I think that article from Ryan is very spot on, and he explains it in terms much better than I've ever explained it. And so I'm glad he wrote that. I'm glad I get the chance to read that, because there are a lot of assertions and anecdotes made about why things are good. Doesn't mean they are. What are you guys guzzling over there? What the hell are you guys guzzling? Do I even want to know? I probably don't want to know. The bites, all of the bites? Okay. Yeah. Makes sense. Catch up on chat. These nuts. I get the annoyance with Martin and the whole clean code naming scheme. It is named facetiously, perhaps to piss people off. So there is an element to what okay, Arvis, there is an element of that. Unfortunately, in order to get like attention, you kind of have to ruffle some feathers. So I think some of you I've talked to behind the scenes, so you know, like kind of like where I truly stand, but I hold back on certain views that I have, because the point that I'm like, my point in when I'm saying these things in public is to, as best as I can, defend the position that I want us to lean more towards. Not that I want us, not the position I want us to be at exactly, but the position that I think we should be leaning more towards. And that means that I have to ruffle some feathers and essentially just be like, okay, fine. So you don't agree with me? Then why why don't you agree with me, et cetera, et cetera. So there is an element of that where it's like, he knows that there's a game to be played to get the attention. Someone educate me on what an alternative take to clean code is, because some parts of it make complete sense to me, but I also don't treat it like Moses from the mountains. You know what, Arvis? This sounds like a great scenario to define standards. Why don't you go ahead and do that, and then we'll define the standards of clean code, and then we'll just move on from there. All right, cool. While Arvis struggles to do that and cries and is in shambles. We'll we'll keep going here. So, TypeScript. Okay? A study from 2022. Now, TypeScript was created why? Why was TypeScript created? Anyone? Let's hear from the class. What is TypeScript meant to do? Justice Bogner is chat name. OOP? Types? Okay. Anyone else? Don't be a piss baby like Spurs. I'm legitimately asking for things to read. I know Arvis is being real and I'm like trash talking him. Yeah, what's TypeScript for? Oh, we've got OOP, we've got types. Everything is an any. It's meant to DX your JS. Yeah. Mulroy. Son of a bitch, Mulroy. Mulroy coming in hot with a banger. YFan, remove a class of bugs. It was made to build VS Code. That's actually true. Yeah, no, Mulroy, I know you're serious. That's actually why it's funny, because it's real. It just made it more funny. I had completely forgotten about that. Then you bring it up as I'm having a sip here. I don't know why it was made, but I like that it at least has an LSP with auto completion and stuff. Sure, fair. Okay, yeah. I'm not going to argue against LSP, auto completion, things like that. I don't really have like, I can see the benefits of them, right? I think it's subjective whether you benefit from those or not, and so that's fine. If you benefit from those, you benefit from those. There's nothing wrong with that. Okay, so to type or not to type. A systematic comparison of the software quality of JavaScript and TypeScript applications on GitHub. Now, I'm going to warn everyone in case there are people watching who haven't been here before, because there are a few, I can tell. Look, if you go back to some of my previous live streams, I'm going to start condensing, like I'm going to slice these up and condense them down into smaller pieces. I've been doing this on purpose, and I'm going to post them on enlightenedprogramming.com. Whoops. Really? There we go. I want to change the color scheme, but I'm posting them here with articles along with the videos. So a written version of the video. Okay. So look, I read these all the way through. It is boring. It sucks. It's not as exciting as me, moving pixels around. All right. I've said this 100 times. The regulars are annoyed that I repeat myself over and over. But if you're watching this as someone new, I get it. This isn't exciting. But I do not see anyone else who is willing to even attempt to take a stab at defending the position that software sucks, and here are some actual academic reasons why they suck, why it sucks. Something at least to sink your teeth into. These things do not mean that like I can de facto state that I am right and everyone else is wrong, or something like that. But they at least help to open up the conversation. So I read through these as much as I can, and I apologize for the mind-numbing material. But we're gonna do this. We're gonna do this as properly as we can do it. I think it looks okay. Maybe what I'll do is I'll do this. Okay. JavaScript is one of the most popular programming languages and widely used for web apps, mobile apps, desktop clients, and even back-end development. Due to its dynamic and flexible nature, however, JS applications often have a reputation for poor software quality. While the type-safe superset TypeScript TS offers features to address these prejudices, there is currently insufficient empirical evidence to broadly support the claim that TS applications exhibit better software quality than JS applications. We therefore conducted a repository mining study based on 604 GitHub projects, 299 for JS, 305 for TS, with over 16 million lines of code. That's not bad. That's pretty good. Using SonarQube and the GitHub API, we collected and analyzed 4 facets of software quality. A, code quality, number of code smells per lines of code. B, code understandability, cognitive complexity per line of code. C, bug proneness, bug fix commit ratio. And D, bug resolution time, mean time a bug issue is open. For TypeScript, we also collected how frequently the type safety ignoring any type was used per project via ESLint. The analysis indicates that TypeScript applications exhibit significantly better code quality and understandability than JS applications. Contrary to expectations, however, bug proneness and bug resolution time of our TypeScript sample were not significantly lower than for JS. The mean bug fix commit ratio of TypeScript projects was more than 60% larger, and TypeScript projects needed, on average, more than an additional day to fix bugs. Furthermore, reducing the usage of the AnyType in TypeScript apps appears to be beneficial. Its frequency was significantly correlated with all metrics except bug proneness, even though the correlations were of small strengths. Our results indicate that the perceived positive influence of TypeScript for avoiding bugs in comparison to JavaScript may be more complicated than assumed. While using TypeScript seems to have benefits, it does not automatically lead to less and easier to fix bugs. However, more research is needed in this area, especially concerning the potential influence of project complexity and developer experience. So then they go over the history of JavaScript, TypeScript, some similar languages, kind of like some of the reasons why TypeScript was created. This sounds familiar. Didn't we read a similar article before? Yes, we've read a similar article before, not this one, but it was one that went over a variety of different languages. It wasn't just JS and TS. Actually, TS wasn't even in that one. It was something else. I don't even think JS was in that one. But yeah, it would have been similar. It would sound familiar. I am curious too. I wonder what they TypeScript performs. It does type checking at transpile time, yada yada yada, beginner friendly. Okay, so they don't really go into like a full history, so that's fine. So we've got JavaScript developed by Netscape in 1995, and then it has different versions, and now it's used by hate crime level things like Node and Electron. TypeScript is a superset created by Microsoft in 2012. It's got different types, different type notations. It's got a type system. So you have static type checks, and then you have dynamic typing, which only checks types during execution, which can lead to runtime errors due to incorrectly assigned types. And so this would be an indication of dynamic types in JavaScript. We all know that. So my string could be a string, or it could be a number. It just changes willy-nilly. And of course, developers, programmers have had issues with this because it's difficult to discern the type that you should be using based on this alone. You can alter the type at any point, and you never know when a programmer down the line, not understanding what you have done, will override the type of your variable. And so therefore, hey, why don't we have types like other languages have, so that we can enforce, some level of strictness with our types, right? And so you can see the difference here. You can't assign my string to 42 because it is set up as a type, and so on and so forth. Okay. So then they go over studies that were related. That kind of like touch on the same thing. So for example, here's one that's a positive for TypeScript, okay? One of the few studies solely focusing on TypeScript and software quality was conducted by Gao et al., with the goal to investigate whether real-world JavaScript bugs could have been prevented by static type checking. They examined the bug fix commits and issue tracking of 398 JavaScript projects from GitHub. As a result, they found that using TypeScript would have prevented 60 of the 400 bugs they examined, 15%. That's not bad. Not a bad number. It's not the number that I would have expected. I would have expected TypeScript to save more, but it's still not bad. Just to be fair to TypeScript. So then they go over, we want to answer the following research questions. Do TypeScript applications exhibit better software quality than JavaScript applications? And do TypeScript applications that less frequently use the AnyType exhibit better software quality? And so they call it RQ1, RQ2. And this is sort of how they break down the hypotheses of different factors of the two questions, right? And so this is how they're going to approach it. Code quality. And so here are some definitions just so we can get a sense of what the heck were they looking at. Frequently used instruments to evaluate code quality are code smells. Example, indicators of low code quality which may impact maintainability. Detecting and removing code smells can also prevent bugs. To obtain the number of code smells per project, we use SonarQube, which is pretty standard. Code understandability is cognitive load, right? So when you're reading it, how much do you understand? Bug proneness is prior to count the bug fix commits. These commits were identified by a script via commit messages containing bug and fix. This is the most accurate method with a precision around 95%. Manual examination of 500 commits classified as bug fixes confirmed this estimate in our sample. Therefore, we operationalize bug proneness as the bug fix commit ratio. So how many bugs were reported, and then how many bugs did you fix? Bug resolution time, which of course just means how long did it take you to fix your bugs. And so they described that. Then they took their sampling. They have they talk about the GitHub API, the breakdown of the files that they had to go over, how many lines of code, the number of projects, having to break out like how they're reading things, like how they're breaking things up so that they can get like total counts. So then they have like total lines of code for each one, total commits, total issues here, so you can break it down by the type. Then they go over how they collect the data. So this is an interesting one. For the bug fix commits, the script also examined if the bug concerns the primary language. Only if the file extensions JS, JSX, Vue, TS, or TSX were involved, the bug fix commit was included. So then they had to work within the GitHub API. Then they do their mathematical analysis on the difference, the delta, and whether it has a significant or an insignificant effect. They go over mean, median with quality differences. Okay, so they break that all down. They go over the any keyword, which, I mean, to me, I don't understand why you'd have a strict typing system and then have any in it. I don't know. It kind of boggles my mind, but it's okay. So they go over it. You can see that they kind of scatter plot their results so they can get a sense of some of the data. Okay, discussion. In this section, we offer potential explanations for our results and discuss their implications. In both questions, we could show that TypeScript applications and refraining from using the AnyType are connected to improved code quality and understandability. The question remains, however, if our data is strong enough to suggest a causal relationship. One argument in this direction could be that TSC, which is the TypeScript compiler, warns about several facets of erroneous and unoptimized code, and thereby combats the dynamic and flexible nature of JavaScript. That is a good thing. Theoretically, this could have an effect on reducing some code smells, but still is unlikely to account for many others or for reducing cognitive complexity. So just because the compiler tells you that there is a bit of unoptimized code doesn't mean that you're going to go and optimize it and improve the quality or, whatever it is. Another explanation could be that TypeScript may be more frequently chosen by experienced developers who may be less likely to introduce code smells in complex code. Experienced developers may also use static analysis tools to identify and remove code smells more frequently. Many of the TypeScript projects in our sample used ESLint, so the assumption that several also use SonarQube or other static analyzers may be reasonable. Another indicator for an experience difference could be much greater popularity of TypeScript projects in our sample. TypeScript apps averaged roughly 2,500 stars, while JS apps averaged only 604. That's huge. It's a huge difference. Despite TypeScript outliers like Storybook, like 68,000 stars, Code Server 51,000, or Grafana 47,000, the median difference is even more pronounced, 84 versus 738. Thanks, Travis. See you later, man. In theory, increased popularity could have the effect of attracting more skilled or experienced contributors. Nonetheless, JavaScript apps in our sample were from the top 15% of popular JS projects and also supported by numerous contributors, making it difficult to believe that their developers may be significantly less skilled than their TypeScript counterparts. Unfortunately, it is not really possible to directly control for the maturity or experience of the development teams with our study design. In other words, they don't have a way to confirm or not confirm that there are more or less experienced developers working on any of the projects that they did in these studies. Contrary to expectations, only a single one of our bug-related hypotheses could be accepted, namely, that a decreased usage of the AnyType is correlated with a faster bug resolution time in TypeScript apps. Now, what's funny about this is that the decreased usage of the AnyType is pretty much for the same reason that TypeScript was created in the first place. Essentially, JavaScript has dynamic types. So you could change a string, a variable that contains a string, into a variable that contains a number. If you set any on a TypeScript variable, you can essentially do the same thing. So you have literally solved nothing except added a complexity build step to your JavaScript. So of course it makes sense that if you're going to remove the keyword any and instead actually use types as they were intended to be used, then yes, you're going to resolve the issue of dynamic typing. Developers feel better because they can trust that the type of their variable is what it says. In comparison to JavaScript apps, TypeScript projects in our sample were more bug prone and required more time to fix bugs. Moreover, a decreased usage of the AnyType was not correlated with fewer bugs. These results are counterintuitive to the theory that TypeScript developers are more skilled and experienced, as more experienced developers should produce fewer bugs. Project popularity, like stars, could be a confounder for bug proneness. More users will find and report more bugs. But We control for this by using the bug fix commit ratio, not simply the number of bugs. In our sample, there is no correlation between the bug fix commit ratio and number of stars. So popularity also fails as an explanation. The results also directly contradict Gao, who found that TypeScript can prevent 15% of JavaScript bugs, and Zhang, who found that dynamically typed languages require 60% more time for bug resolution than statically typed languages. However, both studies did not solely focus on applications, and the latter also did not include TypeScript in their dataset. Therefore, those two studies are difficult to directly map on to these results. One potential explanation could be that TypeScript is chosen more often for projects with very high inherent domain complexity, which could counteract any potential benefits for preventing and fixing bugs. Domain complexity is very hard to measure, though, and we know that TypeScript projects at least have significantly lower accidental code complexity. If we use size as a suboptimal approximation of domain complexity, we see that the median lines of code for our JS sample is 7.2 thousand, while it is 11.2 thousand for TypeScript, or more than 55% larger. While TypeScript with its type definitions is definitely more verbose, it seems unlikely that this alone would account for such a large difference. However, even if we assume the increased domain complexity hypothesis to be true, this still would not explain why a reduced usage of the AnyType is not correlated with fewer bugs in our TypeScript sample. A second potential explanation could be that TypeScript developers simply were more thorough in documenting bugs and their fixes than their JS counterparts. Both the number of commits and the number of issues are substantially higher in our TypeScript sample, thereby presumably supporting this notion. That JavaScript developers committed less could also indicate that they sometimes fixed multiple bugs in one commit, even though this is unlikely to result in such large discrepancies. As before, however, this theory would also not sufficiently explain the missing correlation between the degree of type safety and bug proneness in our TypeScript sample. In summary, the implications of our results are that using TypeScript and adhering to its type safety is associated with increased code quality and understandability, even though it is unlikely that it is directly and entirely caused by TypeScript. That's a very interesting statement. I just want to read that one more time. In summary, the implications of our results are that using TypeScript and adhering to its type safety is associated with increased code quality and understandability, even though it is unlikely that this is directly and entirely caused by TypeScript. Based on the comparison, JavaScript developers should be more conscious about code quality. However, the presumed benefits of TypeScript for preventing and quickly resolving bugs cannot be verified in the study, which hints at a more complicated interaction mechanism. At least in our sample of web applications, TypeScript seems not as superior for preventing bugs as often believed, and JavaScript does not need to hide here. If anything, TypeScript developers should not fall into a false sense of security. Lastly, while refraining from using the AnyType has some benefits, it does not seem to be significantly related to bug prevention. That is, TypeScript developers do not have to try to religiously avoid it at all costs. The effort may not be worth it in several cases. More research on this is needed. Now, if that's true, essentially what you're doing is saving a little bit. You're saving that code quality understandability, which goes back to what Ryan was saying. But you've added a build step or a compiler step in between, and an abstraction in a layer, and that comes at a cost. And the benefits of that cost are very unclear. They're very murky right now. So then they go over threats to validity, which every study does. And so sampling procedure is always an issue for just about every study. There are certain things that they might have excluded, and they realize like maybe it's possible we excluded things that we shouldn't have. They only looked at the top 15% of repositories by popularity. It's not representative of everything. Um, and the fact that these projects also include other things that have an impact on like the project as a whole, right? And so they account for these things. Okay. So I thought this was very appropriate to Ryan's article over here about what are we adding to the cycle and why are we adding it and how are we benefiting from it? Okay, so hang on. People don't pick TypeScript for hard projects. They just do whatever Theo and other web shits tell them to do. That's right, Fear. That's right. Or else they aren't on board with advancing best practices and they're fucking lepers. Yeah. I mean, that unfortunately, that is a reality of tech influencers. And I also have to be careful because I don't want to lead people astray. The what I'm asking for is for programmers to consider fundamentals and why things work the way they do, rather than focusing on learning the thing, like the thing they use to accomplish something, especially when in abstractions. But other tech influencers will not tell you that. They will tell you that the thing, the fundamentals, are too intimidating. You're too stupid to deal with it. So trust us. We've figured out this thing that you don't have to think. Like it just removes. You don't have to ask questions. You just have to do. That's it, and you're good to go. And it's essentially just talking down to you like you're an idiot. And other tech influencers do not get that that's what they're doing. That's not to say that they're trying to be purposefully harmful, but inadvertently that's what they're doing. And part of it might come from it's what they feel comfortable with, and so they just go with it, right? So like many things, your tools don't automatically make you a better craftsman. It's been a while since I've worked with someone who actually knows TypeScript. Crazy how lazy people are when it comes to learning beyond basics. Same goes for Git. Yes. And that goes to the other thing that Ryan had in his article, where the idea that it has to be mutually exclusive is actually wrong. If you look at the evolution of, well, let's take my game, I guess, the video game I'm building. I started in Zig, I moved to Odin, and now I'm in C. And I'll do a video about this, like a short video or something. Those languages, because of the nature of the languages, they did not handhold me. Zig handholded me the most. Odin handholded me significantly less, especially compared to Zig. And C handholds me almost like nothing. And that lack of handholding forces me to consider why I'm doing what I'm doing. And I don't need I didn't have to learn all the intricacies of Zig, Odin, or C in order to have my eyes open to an entirely different set of paradigms that are far more lower level than the abstractions that I was used to working in. And I've used C before. It had been many years and I'd forgotten a lot of things about it. And then going back to it from that path, that those abstractions, if you could consider Zig as kind of like somewhat of an abstraction, a little bit over C, for example, they helped me to like understand C better. That was the correct direction. But other abstractions like React and front-end libraries and whatever, they don't encourage you in that way. What they do is they tell you, no, you actually don't need to know what's going on. All you have to know is what's going on in React land. You're good to go. Zig and Odin bad, C good. We'll rake in reviews. Yeah, I mean, I could, yeah. But Odin good. Odin is good, but also Odin bad. Just in terms of sheer principles. We live in clickbait driven. Yes, it would make for a good title. I agree. If I made the title Zig and Odin are bad, C is good, here's how I did it in my game, I agree a lot of people would click on that. And as someone who deeply cares about my viewership numbers. Yeah, with the soy jack face. Yeah. Yeah, I'm gonna pull a Theo here and do the whole thing. Okay. So now we have something that I thought was really, really appropriate. For example, let's take, well, again, like you could say this about, you could say this a little bit about Rust, just a little bit. You could say this about maybe Zig a little bit in some cases. You can definitely say this about front end libraries like React. You could say this about Node, Electron, for example, Node, um, and Python. So, it's actually kind of difficult to find a study that looks at whether code that is abstracted in order to for the purpose of maintainability is actually maintainable. It's hard to find a study that's like that for like JavaScript land in general. But for Python, that's heavily studied because AI. So this is a study done in, well, this year, not too long ago. How maintainable is proficient code? A case study of 3 PyPy libraries. Python is very popular because it can be used for a wider audience of developers, data scientists, machine learning experts, and so on. Like other programming languages, there are beginner to advanced levels of writing Python code, and you can drop in kind of like any library or language that you want to pop in here. However, like all software, code constantly needs to be maintained as bugs and the need for new features emerge. Although the Zen of Python states that simple is better than complex, we hypothesize the more elegant and proficient code might be harder for the developer to maintain. Insert, wait, I got to do this right. Insert soy jack face, or as I like to do it, um, to study this relationship between the understanding of code maintainability and code proficiency, we present an exploratory study into the complexity of Python code on 3 Python libraries. Specifically, we investigate the risk level of proficient code inside a file. As a starting point, we mined and collected the proficiency of code from 3 PyPy libraries totaling 3003 files. We identified several instances of high proficient code that was also high risk, with examples being imp list comprehensions, enumerate calls, generator expressions, simple dictionary comprehensions, and the super function. Our early examples revealed that most code proficient development presented a low maintainability risk, yet there are some cases where proficient code is also risky to maintenance. We envisioned that the study should help developers identify scenarios where and when using proficient code might be detrimental to future code maintenance activities. So then they go over Python, kind of like a little bit of a history, how it's used, the libraries that they picked, FPDF2, npm math, and PyTorch geometric. And so they break down what the libraries are and how they looked at the proficiency level. So safe versus risk, right? You can kind of see that there's a pretty good, correlate value here that you can infer. It's sizable. So have a look at some of the proficient calls. Simple list comprehension is an advanced level use case. it is risky. Enumerate call is master level. It's risky. Generator, advanced level, risky. Zip call, master level, risky. Superfunction, master level, risky. Now, the superfunction master level safe has way more cases of safe than risk, right? The simple list advanced safe has way more cases of safe than risk, and so on and so forth. So what they're essentially saying here is that it is not clear cut. It is not like just a straight up, well, every time that you use one of these more proficient or clever or abstracted tactics to implement your code, you're going to get the benefit of safer code because someone smarter implemented this thing that you now get to use. Interestingly, we observed, it's a very short paper, we observed that some cases with similar classes appeared in both the risky and safe categories. This suggests that even similar cases can result in either low or high maintenance requirements. It would be good to explore these findings in the future. So this is a small study based on only a few files, but you can imagine what it might look like if you take a vast swath of usage, not just in Python, but also like in JavaScript, for example. And I think actually this would be impossible to do in JavaScript. It might even be impossible to do in languages like Rust, maybe, where there's so much going on. You have so many interdependencies and so many things running all at the same time that you couldn't properly cover the spread, so to speak, right? But I thought this was a good one to just kind of highlight the fact that it's not as clear cut as you might think. Okay, now let me see. I have a few here. Not that one. Nope. Nope. Right. Okay. I think it was some of these. Okay, let me get the let me do an ad break on the Twitch side because Twitch is telling me. And then let me set up the okay, right. I was gonna go over this. That's right. This one I don't think I was gonna do. Oh yeah, and then this. Now this is 2018 though. 2021. Okay. No. We're gonna do this one next. Okay. And then we're gonna do hiring, I think hiring practices, and that'll be that. I'm just waiting for Twitch ads to be over, folks. There's like a minute and a half left. Okay. So yeah, we're gonna talk about video games and bugs in video games. A minute left. No problem. How's everyone doing, by the way? If there's anybody on X, hello. If there's anybody on I can't remember all the other places I restream to. Just hello, everyone. I'm just waiting for Twitch ads to be over, and then we're gonna get going. "30 seconds. Okay. We're ready. So, something that I figured would be of interest to everyone who would end up watching this now or later on video is bugs inside of video games, because a lot of us are gamers. Now, there's a logical series of well, it's not even a series. It's a very few set of logical steps that you should be able to jump to. So if I say software sucks these days, programming sucks these days, programmers don't understand as much as they should, web development is absolute dog shit, etc. A lot of the pushback I get is along the lines of, no, actually, it's better than ever, because it allows us to do extremely complicated things with much bigger team sizes, and we get to move faster, we get to build more features, etc. Now, there's a jump that's made there. There's something missing, which is if programming and languages, libraries, frameworks, software, web, all of these things, if all of these things have, as a general rule, become better, then what you should see is a decrease in bugs. You should see a decrease in security vulnerabilities. I mean, there was just one today with, I think, the Department of the Treasury, the Treasury Department in the US. You should see it like, not this one. I think it's this one. No? This one. Like, this shouldn't be going crazy. This shouldn't be effectively doubling in but 2 to 4 years, right? Because everything should be better. We shouldn't be seeing more problems with video games, or regression in, say, graphics or gameplay mechanics, or things like this, especially when hardware is getting better too. Which is also another common argument I hear, which is like, hey, we can afford the cost of some things not being as performant as they should be because hardware is so much better these days, et cetera, et cetera. So are games getting better? Bugs that persist into releases of video games can have negative impacts on both developers and users, but particular aspects of testing and game development can lead to difficulties in effectively catching these missed bugs. It has become common practice for developers to apply updates to games in order to fix missed bugs. These updates are often accompanied by notes that describe the changes to the game included in the update. However, some bugs reappear even after an update attempts to fix them. In this paper, we develop a taxonomy for bug types in games that is based on prior work. We examined 12,122 bug fixes from 723 updates for 30 popular games on the Steam platform. We label the bug fixes included in these updates to identify the frequency of these different bug types, the rate at which bug types recur over multiple updates, and which bug types are treated as more severe. Additionally, we survey game developers regarding their experience with different bug types and what aspects of game development they most strongly associate with bug appearance. We find that information bugs appear the most frequently in updates, while crash bugs recur the most frequently and are often treated as more severe than other bug types. Finally, we find that challenges in testing, code quality, and bug reproduction have a close association with bug persistence. These findings should help developers identify which aspects of game development could benefit from greater attention in order to prevent bugs. Researchers can use our results in devising tools and methods to better identify and address certain bug types. So again, they go over things like, yeah, bugs are going to cause a loss in sales. It can impact the users. They will not enjoy the game. They can lose hours of progress. It can create misunderstandings between players. For example, if you're doing a multiplayer game and there is a bug, there is a frustration in the multiplayer game, whereupon the multiplayer game is no longer fun. Even though there are negative consequences to bugs, it is common for games to release with bugs that are fixed through subsequent updates. So I remember the good old days when you would buy a physical hard copy of a thing and you just got that thing and that was it. We have it so good now and we still can't get it right. In 2014, for example, over a third, I really want to drive this point right the fuck through your skull. In 2014, for example, over a third of big budget games released on Xbox One, Wii U, and PS4 received an update within 24 hours of the game's initial release. Tell me, do you think this has got better or worse since 2014? 10 years later, do you think it's become better or worse? Are games releasing fewer updates in the first 24 hours, or are they releasing more updates in the first 24 hours since 2014? It's not, I mean, it's a rhetorical question. It answers itself. I just needed an excuse to take a sip. Shout out to all my homies who bricked their Wii U on Christmas Day because of like a 10 gig firmware update. Yeah. The differences between the development of games and development of traditional software could explain the appearance of these bugs. Prior research was done to identify the differences. For example, games typically do not have strict functional requirements. Unlike traditional software that is usually meant to accomplish a particular task, generally, the primary requirement of a game is be fun. As a result, requirements tend to be more informal and subject to change as developers continually refine the game to be more enjoyable. This is a good point. The nature of a game can change if you're going to constantly update it based on user feedback. That's fair. Additionally, game development teams are often more diverse in terms of team member background and expertise. For example, games often contain a large number of graphical assets, which requires greater participation from designers and artists. One important difference that could explain why bugs may not get detected before releasing relates to the difficulty in comprehensively testing all aspects of a video game. Hang on. Developers have difficulty writing comprehensive tests because games can have a significantly large number of possible user interactions compared to other types of software. Players can act unpredictably when playing games. And automated testing tools struggle to replicate the full range of interactions as human players might attempt when playing a game. As a result, many games release with undiscovered bugs that only reveal themselves once customers begin playing the game. Now, I would argue that in reality, this is no different than the web or software. I actually think that this is a common thing that happens in web and software too. I do not think that video games have some kind of distinct angle on this. It is often the case that you'll release a piece of software for a desktop application or a mobile app or a website, and a user will do something that you did not expect them to do, is not covered by a test use case, etc. One way developers address previously undetected bugs post-release is by applying updates to their games that fix these bugs. These updates are usually accompanied by update notes, a textual description of the changes in the accompanying update. These update notes are often published as news items on the game's website. While some updates might include content changes or additions, other updates might only attempt to fix a small number of severe bugs. Some of these smaller updates are referred to as hotfixes. These updates are typically meant to remedy more pressing issues or bugs that need immediate attention. Additionally, some bugs might reappear or recur in multiple updates. There exist cases in which developers have attempted to fix a bug in one update, only for that bug to reappear in the game anyway, necessitating another attempted fix in a later update. For example, in the game Warframe, the notes for an update posted in August of 2019 included a bug fix statement that said, "Fixed inability to complete the Mastery Rank 12 test if you fall off the starting platform." In September of 2019, the notes for a later update also included an identical line, which implies that the August update did not successfully fix the bug. Previous research has focused on creating a taxonomy for video game bugs. While this taxonomy provides a solid basis for categorizing bugs in games, a cursory examination of bug fixes described in game update notes indicated that this taxonomy did not cover all the bugs addressed in these updates. So there's some subtlety, and so essentially they wanted to expand the taxonomy, and so these are the questions that this paper asks. What are the most frequently fixed types of bugs through game updates? What are the most frequently recurring types of bugs? Are all types of bugs equally severe in negatively impacting the game experience? We have provided our data set of 12,122 labeled bug fixes and a report of the survey responses. There is some related work. So they talk about other studies that have been done that are related to what they're talking about in this study. So, for example, this Greek guy, Ampadzoglu, performed a case study on a collection of open source Java games to find possible correlations between the application rate of design patterns, the defect frequency, and the debugging efficiency, which is a study that I'm going to go through later in another somewhere in the future, because these are all good studies that also talk right back to the article we read at the beginning. So then they go over that. They tell you how they collected the data. For our data set, we used update notes from the most popular games on the Steam platform. We chose the Steam platform because Steam is the largest vendor for games on the PC system. Check that sent right after 8. Or was that here? Borelli et al. Identified 7 types of bad smells in game projects that were created with the Unity game engine and presented Unity Linter, a static analysis tool designed to help Unity developers to detect these smells. They found that certain patterns, such as the adapter pattern and observer pattern, exhibited such correlations with defects in debugging, but could not identify causal relationships. Was there a reason you wanted me to read that, Laugh? Observer pattern. Wow. Yeah. Okay. Because you were wondering what it was. Okay. To identify a selection of popular games, we found Steam's list of games that had the highest number of players on June 23rd, 2020. We chose the top 30 games from that list, excluding items that were not really games. The list of games used for this paper can be found in Table 1 and the genres. For example, the most recent update we collected for the game Counter-Strike Global Offensive was released on 2020, which meant the earliest update we collected for this game was released on July 16, 2019. And so there's a dating on updates, right? So they continue to talk about that. Then the types of bugs. We identified that there were bug fixes that did not fit in any one of the existing types. Hence, 2 of the authors jointly applied open coding. First, we generated short descriptions of the initial 11 bug types based on the descriptions from Lewis et al. So Lewis et al. Is the base paper where they get all their bug types taxonomy. As we labeled bug fixes from our data, if we found a bug fix that did not fall under a currently available label, we created a new label. So they essentially just did their due diligence on making sure they had as many labels as they could. For example, one bug fix for the game Black Desert Online said, "Fix the issue where running left or right was impossible when transformed into an immortal persimmon knight." While part of this bug related to incorrect position of a game object, the inability to perform an action seemed to be the core problem. Therefore, the action label was applied instead of the position of object label. They're trying to be careful about how they categorize or taxonomize the bugs. Bug recurrence. So they had to manually search through the data to find all recurring bugs. Well, that's what they would have to do. At the same time, we discovered a purely automated approach could also lead to problems. A cursory analysis of repeating bug fixes in the data revealed that some repeating lines were generally written. It was unclear whether or not the fix was applying to the same bug each time. For example, the game Ark Survival Evolved had 5 updates that included the line "fixed a server crash." In this case, it was not apparent whether this line was referring to the same bug each time or different bugs that caused crashes. Conversely, 2 updates for the game Dead by Daylight both contain the same line: "fixed an issue that caused a crash when changing the graphic quality settings during a match in the Red Forest maps." Here, the apparent cause and effect of the bug are identical. Changing certain settings in a certain context causes the game to crash. In this case, both lines are likely referring to the same bug. We were skeptical that an automated tool would be able to differentiate between these 2 types of recurring bug fixes, so we chose not to use a purely automated approach either. We ultimately decided on a hybrid approach. We would use an automated approach to limit our analysis to a smaller collection of bug fixes, and then manually evaluate these lines to find the true recurring bugs. So they talk about that. So this is the table: the game title, the genre, and the number of analyzed updates. So the maximum date would be June 23rd, 2020. Counter-Strike Global Offensive, 36. You can see it all here. Path of Exile, 87. Damn. Shit. Ark Survival, 80. Grand Theft Auto, 3. Terraria, 5. Sid Meier's Civ 6, 3. Warframe, 98. Interesting that they're mostly multiplayer. True. The Elder Scrolls Online, 25. Hearts of Iron, Sid 5. Black Desert Online, War Thunder, 92. Sponsored to you by War Thunder. And so then they go types of bugs found in update notes. So game graphics, implementation response, an NPC or AI does not behave in the intended manner, game audio, interaction between object properties, mostly multiplayer and mechanically complex. That's right, yeah. Game camera, interrupted event, object persistence, so collisions, objects do not enter and exit states properly, game crashes like a triggered event, user interface, players are able to improperly and unfairly gain game benefits, so like exploits. Bug severity, and so they go over how they determined whether or not something was urgent. So things like they fixed it right away, for example, that would indicate a sense of urgency. If it was a hot fix, or if it kind of like came on its own, like they pushed out a fix and it was kind of like its own thing, it probably means that it was an urgent fix, right? And so there's a sense of urgency that you can get. They also explain that there are certain types of bugs that have an automatic level of urgency, as opposed to certain bugs that are urgent simply because they may not have like a massive breaking issue, but there's enough that it needs to be fixed right away. Otherwise, there's a problem. So then they created the survey. We created a 12-minute survey using the Qualtrics survey system to assess game developer perceptions of the types of bugs that appear in game updates notes. So this is from the perspective of the developer, right? What kind of bugs appear when you're fixing these bugs in a game update? First, the survey asked participants certain demographic questions, such as years of experience, number of people in the org. We also asked participants if they had experience fixing bugs for updates to video games. The next section asked participants about their experience with different bug types in our taxonomy. For each of the 20 bug types, we asked participants to rate on a 5-point Likert scale their level of agreement that the bug type was likely to have a severe negative impact on the game experience. Participants were then informed of the 3 most frequent bug types across all updates and were asked if these results matched with their own experience. They were also offered to explain why they believe these bug types and other bug types they commonly encounter appear so frequently in game updates. Similar questions were also asked for the frequently recurring bug types. Finally, participants were asked about the aspects of game development related to bug recurrence and the challenges in identifying and fixing bugs. To find participants, we identified GitHub repositories for games and game-related tools that had been marked as noteworthy by other GitHub users. We sent the survey to GitHub users who had contributed to these repositories and who had made their email addresses visible to other users. Additionally, we sent the survey to developers of the games examined for the study whose email addresses were publicly listed on the developers' websites. We also made the link to the survey available to a collection of game developers with the intention that they would apply, snowballing to spread the survey to other developers. The survey was sent to 630 contacts. 16 of those invitations were not delivered successfully, yada, yada, yada. Overall, we received 47 responses. That's a response rate of 7%. Other important studies in the software engineering field have reported response rates ranging between 5.7% and 7.9%, indicating that our response rate for this study is satisfactory. Now, it would be nice if we had, like, say over 100, but still, I'll take a room full of 47 developers with, a varied amount of experience, kind of giving me a little bit of feedback on, what they think of things to kind of get a sense, right? The results: frequent bug types in all updates. Figure 1 shows the frequencies at which each of the 20 bug types appeared as a fix in any game update from our data. Info being the highest, graphical being the second, action being the third, UI being the fourth, trigger being the fifth, and so on. What was info? Info is let's see. What is info? Category information. Information about the game world is not conveyed to the player correctly. That's what it is. Right here. Information about the game world is not conveyed to the player correctly. The highest. The three least frequent bug types are camera, interrupted event, and exploit. The 2 most frequent bug types, information and game graphics, cover largely non-interactive elements of the game. This runs somewhat contrary to findings found by Santos et al. That suggest some of the difficulties in testing games are due to challenges in testing interactive elements. If the most frequent bug types are not necessarily interactive in nature, perhaps automated testing might be more effective at catching these more common types of bugs. For each of the 3 most frequent bug types, survey respondents were asked if they frequently fixed bugs of that type in game updates. So you see the distinction here is they tracked bugs that were reported in the release notes. Then they asked the developers at hand, does this match with what you experience when you go to fix bugs in games? 50% of respondents said they frequently fixed information bugs. 40% said game graphics. 67% said action bugs. When asked why certain bugs might appear frequently, respondents gave a variety of responses. For information bugs, some respondents referenced priority concerns, such as the one in the following survey response. Developing mechanics is the main focus, and usually information-related components are pushed down to the last of the pipeline as a deadline approaches. They are not done right. Other respondents noted that correct information may be difficult to identify if that information is the result of various calculations involving complex states and interactions. This information could also be buried in data files that testers may not be able to locate. Incorrect information might be missed because the correct information may not be accessible. You could imagine a scenario where you have static information on screen, like some calculation of a location in the game, where the developer is looking at it, it is wrong, but the developer will not do the calculation in their head. They are dependent on a pre-existing algorithm or some kind of function that gives them that location by operating those like mathematical principles, and they just kind of assume, well, it seems right, let's go with it, right? Because it might be too complicated to just quickly do in your head and do a quick gut check whether the static information you're seeing on your screen is correct or not, right? There are a number of reasons for this. Survey explanations for the frequency of information bugs include low priority compared to other aspects of the game and difficulties in finding the correct information. With respect to game graphics bugs, the most cited reason by respondents to their frequency and updates was due to the complexity of the subject. Computer graphics is one of the most complex disciplines to work with and need highly experienced programmers to make sure that everything just works. Respondents also cited the large number of cases that need to be tested. It's fairly simple to miss visual corner cases in testing. Additionally, some responses seem to speak to the difficulties in properly assessing the quality of game graphics. One respondent pointed out the game graphics can be subjective. What looks like a graphical bug to one tester may not look like a bug to another tester. Another respondent mentioned that the correct graphical qualities of the game might be highly specific and require fine-tuning to get them right. Graphics can be delicate. It can take a lot of tweaking to get something to look just right. One response noted that graphics are considered a lower priority to fix before production than other game elements. Observation 3. Survey explanations for the frequency of game graphics bugs includes complexity, large size of testing state space, and evaluation of graphics quality. For action bugs, many of the respondents spoke to complexity in testing as a reason these bugs might appear frequently in updates. Each possible action gives the player a new way to interact with the game world. As the number of possible interactions increases, there is a greater chance that these interactions might conflict with each other. Testing all possible conflicts can be difficult to do within the development timeline, especially when dealing with actions that may or may not be executable depending on the game state. Games often have a large number of available actions, only some of which are available at a given time. The results of actions often depend on context and sometimes randomness, and actions may depend on or be changed by previously performed actions. While testing every possible action might be feasible, testing every possible sequence of actions in every possible sequence of contexts is usually combinatorially impossible. You would have to be Doctor Strange. Respondents were also asked if they frequently fix bugs of any other type from our taxonomy, why these bugs might be frequent. Crash bugs were identified as frequent by 2 respondents, with one respondent attributing this frequency to not properly checking for input sanity. Another respondent mentioned exploit bugs, stating players are good at finding them. Another respondent, who worked with multiplayer games, referred to bugs related to desynchronization of players. Under our taxonomy, this bug would fall under the implementation response label. Another user mentioned bounds bugs as a frequent concern, especially for 3D games, explaining that the collision and physics system in a game tend to produce edge cases somewhere that leads to bounds issues. Recurring bugs. Frequency of recurring bugs. Crash. It is overwhelmingly huge. Now again, I just want to point out again, if programming is in such a fantastic state, it's never been better. Why are we seeing an increase in these issues? then its graphical, then its trigger, then its position, and so on. For each of these top 3 bug types, survey respondents were offered to explain why these bug types recur over multiple updates more frequently. When it comes to crash bugs, multiple respondents cited the difficulties in identifying the actual root of the crash. When fixing a crash bug, it is easier to find the single caller that passed bad data in the crash report than it is to ensure that all callers pass good data. Other respondents spoke to how other changes to the game can easily cause the crash to reappear even after fixing it. Due to how interconnected most things in games are, it is easy to reintroduce a crash after initially fixing it. With respect to why game graphics bugs would recur frequently, the responses were more mixed. One respondent mentioned that games graphics can be interdependent and cascade through fixes, while another expressed experience with having to deal with unforeseen edge cases. A different respondent reiterated the delicate nature of game graphics. A previous fix to a graphical component of the game might not have been sufficient, and further tweaking might be required to get the graphics just right. Another user pointed out that graphics bugs are the most apparent thing for the player to notice. Building off these responses, it is possible that since the quality of game graphics can be subjective, and because players more readily notice the quality of game graphics, these kinds of bugs recur more frequently because players are more likely to notice graphics that do not meet their personal quality standards, which could mean that they're more likely to express their satisfaction to developers. Because few respondents claim to see frequently recurring triggered events bugs, there were not many explanations as to why these bugs might recur frequently over multiple updates. Still, some responses speak to the large size of the test space. Events can often be triggered in many different ways. Making sure every way works is tricky and time-consuming. When asked if respondents had seen any other frequently recurring bug types, one respondent pointed to action bugs, stating that those bugs recur often for the same reasons as crash bugs. Other respondents spoke more broadly, identifying reasons why bugs in general might recur over updates. Sometimes bugs recur because some careless guy removes your fix when merging his or her code. Wait just a second. Do you mean that Git does not prevent you from being stupid? It has to do with whether management allows us the time for testing before they push out the newest code. We've all heard that one before. Bug severity. And again, crash takes the lead. Persistence and trigger followed not very closely. Okay. Agreement level to whether selected bug types are likely to have a severe negative impact on game experience. So this is probably after this, but we can have a look at that. So strongly agree, neutral, disagree, strongly disagree. So the crash obviously is going to have the most impact on game experience. And then it's going to be action. And then it looks like exploit wins by just a little bit. And then camera. In terms of strongly agree, right? General agreement, though, that's a little bit different. So you can see that even the subjectivity of what developers assume in terms of the issue that is presented and how it affects the game. Crash bugs appear to be the most severe bugs in both data sources. Action bugs, the second most severe, do not rank as highly when looking at the mined data. Interestingly, exploit was the bug type that received the third most strongly agree. But it had the lowest severity rate from the mined update data. So what might be a reason why developers feel that an exploit bug has a huge impact on game experience, and yet the severity rate of treating exploits is the lowest? Hey, Coding and Focus on YouTube, if you want to drop a link, you can drop a link. But I'm not going to be, I won't do it now. I'll save it for another stream, but I can do it. Bug fix association with game development processes. Survey respondents were asked, in your opinion, what aspects of game development, testing, designing, etc. are associated with bug recurrence in your current project or in other game projects in which you participated? 16 respondents mentioned testing as a component of game development that had a strong association with bug recurrence. Some of these responses mentioned how a lack of testing in general was linked to bug recurrence, while other responses spoke about the lack of certain kinds of testing, such as automated testing, integration testing, and cross-platform testing. This doesn't come as any surprise. Finally, respondents were asked what they believed were the main challenges in identifying and fixing bugs in video game development. Adequate testing. Identifying origin of bugs or reproducing bugs. Reproducing a bug often requires a large time investment to reach the state in which it is apparent. Games, specifically, are huge, loosely connected systems. Bugs often depend on more than one of these systems having a certain state. Code quality. The hardest part is finding an appropriate solution to a bug that isn't hacky and is future-proof to later additions to the code that might break the bug fix again. 2 responses mentioned development schedules, lack of QA, faulty development schedule, low focus on code quality. 2 responses mentioned unforeseen bugs that only appear in particular situations, such as bugs arising out of specific hardware setups, bugs that occur only with some OSs or hardware. The choice of programming language can lead to issues. Using languages with a weak memory model, such as C++, makes it hard to identify bugs caused by memory corruption errors, such as use after free. C++ in shambles. C++ in shambles. So then they talk about the prioritization. They essentially they just kind of like summarize how they prioritized. And then threats to validity, like, hey, we didn't get enough people responding, etc., etc. Okay, I'm gonna run the. I'm gonna get the Twitch ads over with, and then we're gonna do a little bit more. Hey Zada, it's a paper about bugs related to video games. But I've been going over a bunch of papers and articles on the stream. It's on my YouTube. It's live. It'll be a live on my live tab and on YouTube. None of them said scope of game too large. Apparently not. Definitely not. I'm too dumb to sanity check inputs, as mentioned earlier. Yeah, replace it with Rust. That'll solve your problems. Right. So I think this is the thing. Yeah, added borrow checker. Yeah. This is the thing that stands out to me about this particular study is there is nothing new that I heard about the problems being faced. Unity is so great, Unreal Engine is so great, all these things are great. It's never been better to create a game, etc., etc. What problems have we solved? We haven't really solved anything with these abstractions. Based on the study of the top 15% of video games on Steam in 2020, the exact same problems are being talked about. We haven't solved any of them. In fact, what we've done is we've actually made it more complicated by using more abstractions and layers of abstractions. Hey, Battle Gnome, I'm a front-end 3D dev looking for a more efficient stack. Front-end 3D dev. So, like, what are you using, Battle? Like OpenGL or something? Or are you talking about like front-end like web? Or is it like WebGL, WebGPU? Yeah, that's why I wanted to see the line with adapter observer pattern. Right. Because the observer pattern was called out as um, quite problematic. And it's like, well, what have we solved? WebGL libraries? So what's wrong with the stack that you have right now? Like, what is the stack you're using that's not efficient? Maybe we can give you a hint. I'm sure the barrier to entry being lowered doesn't help. The self-report about memory management is telling to me. Yeah, yeah, the exactly. You when you lower the barrier to entry, when you say, "Oh, everybody can write front end and now back end with React Server components and now native mobile apps with React Native and all of this stuff," when you lower the barrier to entry, you're not actually solving problems. You're actually like the initial article at the beginning of this live stream, you're making problems bigger and then you're kicking those problems down the road. Lots of TS and JavaScript. Remove the TypeScript. Just do vanilla JS. Just do vanilla JS and WebGPL. That's going to get you a lot farther. It'll be more efficient in terms of like actual. If you take some time, Battle, to learn the fundamentals and stick to the fundamentals of JavaScript, and you're just very disciplined and strict with yourself, you can take it very far. You don't even need TypeScript. Astro Solid Babylon 3. I'm actually coming from 3D modeling background. Yeah. So you could probably just get away with like just three. Just three JS and vanilla JavaScript. You really don't need much else. If you want to be efficient as in like it is performant to run these things, remove everything but vanilla JS and maybe keep 3JS because it does some stuff for you that you don't have to handwrite. That's what I would say. That's the ledge you wanted to be talked off of. Yeah, so Battle, I'll take a second here. Look what I'm doing. Um, I'm writing a video game in C. Here, I'll go into hacker mode. Okay, I'm writing a video game. So the game state manager is in C. Since you're a 3D front end dev, you'll understand this. The game state manager is in C. I compile it to WebAssembly, and then in the browser, I just use vanilla JavaScript. Hang on, let me pop this open here. Get rid of word wrap. I just use vanilla JavaScript everywhere and run the WebAssembly. And my vanilla JavaScript talks to the WebAssembly to figure out the game state. And then I render everything using regular div elements. There's no canvas. There's no GPU acceleration or hardware acceleration. The DOM is not as slow as people make it out to be. That's all I'm doing. And if I want to have 3D, check this out. I'm coming for Unreal. I have 3D. CSS, vanilla CSS. You see how my little characters are popping up there? And then I can move them around. And I can move while I do CSS 3D. This is all vanilla. You can do a lot with extremely little. There's a reason why I wear the Iron Man hat, because I am Iron Man in the cave with a box of scraps building an Iron Man suit. So simplify the stack. Okay. So the last thing I wanted to go over was this entire premise that the United States needs to open up their H-1B visa program because there's not enough talent. Why do I think TypeScript is that bad? Because it offers you nothing. We literally just read a paper where it does not reduce bugs. In fact, it can sometimes increase bugs, and it has no seeming effect on anything except for pretty much readability and maybe some code quality. So, like I went through that paper. So here, this one, you can go back in the live stream on YouTube when this is done. It's this paper. So essentially, bug proneness and bug resolution were not significantly lower. The mean bug fix commit ratio of TypeScript projects is more than 60% larger, and TypeScript projects needed on average more than an additional day to fix bugs. So, like, why? Why? They're all little sprites. Svelte just got rid of TypeScript. Yeah. Yeah. Okay. So to continue with this is like the final thing I wanted to go over. So there's an argument that was being made by essentially Elon and Vivek that there's not enough good talent in tech. There's people don't know what they're doing in America. They're too lazy in America. They're too worried about how things look and not how things work. And I actually kind of agree with them. And you can actually see that with front-end development. Front-end development is mostly about how things look, not how they work. They want to try and make things look good, but when it comes time to use them, it's like asking, you know, like what Vivek said, right? Like the jocks at school, not the valedictorians. It's the jocks and the sports people. It's like asking them to do like a complicated math question. They're just going to look at you and go like, but I can throw a ball really far. That's front end development. Okay. So I kind of agree with that, but here's the problem. Even if that's true, do we even know how to identify whether a programmer is good or not? And something I noticed today, let me see if I can find it. Let me go over here. Let's see if I can find the actual thing. I'm not going to be able to find it now, am I? There was somebody who was saying, oh, I know who it was. Oh, I'll be able to find it now. Let's see here. Right here. Okay. Here we go. This guy. And Vic. I have a very simple question I ask during phone screens. Print each level of a tree on a separate line. 90% of computer science grad candidates just can't do it. Someone needs to investigate these universities. And so here it is. You have a binary tree. And so the idea would be that you would iterate over the binary tree and your output would be here. 1, 2, 3, 4, 5, 6. And then subsequently, if you can't instantly solve it in your head, you have some studying to do. This is gatekeeping, self-jerking, pleasuring. Basically, he's just masturbating in public. That's what this is. This is just public masturbation. If you could solve a problem like this, does that actually indicate that you are qualified for the job? And that's what I want to get to. Battle on YouTube says, I just want to make sure we bring in programmers who embrace the culture and our common values if they come here. I agree. Battle. I agree. The raggy depends on the job. It does depend on the job. I actually agree with you completely. I completely agree with you. There are some jobs out there which you are actually going to need to do something that is akin to this almost exactly. 100%. I agree. But this is a vastly overused mechanism of determining whether someone is good or not. And my argument is that 80 to 90% of the time, it actually gives you no insight as to whether a programmer is good or not. None at all. So, this is an article from someone who is it's kind of like a mini advertisement for this thing called CoScreen. However, I pre-read the article, and there are some good, in my opinion, there are some good takes. So we'll just touch on a few things and kind of lead into why I think we don't even know. So we just went over like a whole bunch of stuff of like why we can't even properly manage talent that we might already have, let alone determine talent as part of the hiring process. When interviewing for US jobs and stuff, I get to confuse why they're asking for algorithm solving. Yes. So here's my take on how you should do hiring questions. I want the entire industry to encourage programmers to pick any language, library, or framework they like, does not matter which one, and tackle the most insane, complicated project they can come up with. Something that they want to do, something that seems cool to them, that will suck up their attention and time, even if they can only put in a few hours a month or something like that into it. Then I want them to come to me during the interview process, prepared to talk about that project. The idea is that the programmer should be expected to not finish the project and not to do it properly. That's not the point. The point is to make the attempt and to learn a whole bunch of stuff from a bunch of complicated things that they put together. So I would be asking questions like, what goals did you set out for the project? What makes this project complicated? How did you attempt to approach it? Talk to me about the code you use, things like that. And the reason why I like that is because it's not me asking a question that's like almost feels like a gotcha question to the programmer, because some programmers will literally they might be extremely smart, but their brains will stall if you ask them a question that feels like a gotcha, like, hey, can you solve this question I just came up with on the fly? Right. And then the other thing is I can tell a lot about like how they put the project together, how deeply can they go into the technical aspects, things like that. And it's a more relaxed environment because they're talking to me. I'm not talking at them. That's what I would like to see. We have 9 of the 10 best engineering schools in the US. Someone needs to be held accountable for our death of qualified STEM graduates. I've been a battle for the last year and some months that I've been streaming. I've been talking exactly about this. The tech industry has painted itself into a corner. We have catered to the lowest common denominator of programmers in order to make them feel good, not actually produce something of value in terms of like quality stuff that runs efficiently on your CPU, doesn't crash, doesn't cause issues, doesn't eat up all your RAM, things like that. And we've just let that go hog wild because everybody's making money. Nobody questions it. I built a website to tackle this problem because there's another unspoken problem too, but we'll get to that. If you do an interview like that, you're basically training the dev beforehand. You're ensuring that the dev will be better at the end of the process. Yes. Yeah. I think I know what you're talking about. We literally show real world code and ask things about it. Yeah. Okay. In the not too distant past, I found myself in the position of hiring some of the core engineers that would drive a fledgling telehealth startup towards what I hoped would be a glorious and successful future. Since the founding team of a company is so critical to its long-term success, I based my ambitions in the collective wisdom of the internet. What could go wrong? And of course, looked towards the FANG interview process and especially Google. I was the first full-time engineer hired at the video interviewing pioneer HireVue and have a decade of experience in the HR and interviewing technology space. This experience made me a firm believer in the structured interview. Line up a set of candidates, give them a set of standard questions in a structured fashion, and look for genius in the answer of routine questions. What could be fairer and more organized than lining up candidates one by one, question by question, rating each, and just hiring the best rated out of all, like cattle, like sheep, because you're all dum-dums. This is essentially the hiring process right now. You're all a bunch of morons, so fit within this paradigm because you're too stupid to think anything else. And frankly, we're too stupid to ask of anything else. And just line up like sheep and be good little sheep and baa for me, and then we'll give you your money and you can come put your butt on a chair and produce code. Deep inside, I'd always suspected coding interviews were in large part bullshit, haven't we all? I hired a senior level engineer who absolutely aced the canned online coding challenges we gave him and all of the other stages of a highly designed and structured interview process. I was very excited and convinced that he would be a solid contributor to our team given his extensive technical knowledge and demonstrated ability. The first signs of trouble came when he had issues just checking out our code base. He then spent a week tailoring his IDE and development tools before he could start working on the project. As a fan of highly tailored Vim and shell configuration and environments, I chalked this up to quirky perfectionism. The real revelation came when I went to pair program with him on his first story, a fairly basic time zone problem. This is when I noticed it seemed to take ages for him to type out a single line of code. He would seemingly get lost navigating around the project and was confounded by reading other people's code. After just 20 minutes of sitting side by side with him, it was clear that while he was extremely academically savvy with the subject of programming, he was not savvy with the act of building software. Second job pre-work volume is untenable for a lot of people for most product work. Just rip a feature out of the real product, have the interviewer sign it, and NDA, re-implement the feature together. That could work too, the Raggy. Yeah, that could work too. Essentially, if you can get the person who's doing the interview to talk more as opposed to you asking questions in order to get them to talk, if they can naturally talk, so they have something that they can work with, that they can just talk to me. I'm not here to put pressure on you. That I feel is much better. And it's better if it comes from from something they're doing. That's something that is attention grabbing for them. And then they will talk about it more deeply. The skills I had tested for would likely have made him the perfect fit for some type of deep engineering research project, but it was clear he wasn't the right fit for us. I lament this decision to this day because given our early stage, I was forced to let him go, and I feel my poor vetting meant consequences for him. Even after following all of the best recommendations and best practices at the time, how could the result end up so very far off my intended mark? Deep inside, I'd always suspected coding interviews were in large part bullshit, haven't we all? How could I have designed the interview better to discern practical skills over purely academic skills? It's something I asked myself a lot in the following years, and something I have only recently started to begin to understand by interviewing entirely remotely through the pandemic using CoScreen. Developer interviews the status quo. Much has been written on the current state of developer interviews. When you think of software engineering interviews, many things come to mind, from the much maligned FizzBuzz coding challenge, which determines if a candidate knows the modulo operator exists. Obscure potshot domain-specific questions being asked during a classic whiteboard interview. Bipartite graphs was a favorite at HireVue. To implementation of basic data structures like red-black trees. I don't even know what that is. Everything now seems to boil down to coding challenges, where developers are asked to go through an array of canned, hacker-ranked challenges and produce some code to solve an eclectic walled garden problem. Either that, or it's a battery of in-person whiteboard interviews where candidates answer a barrage of fanciful questions, often the same questions over and over, which seem to be more a test of basic human endurance, willpower, and mental stability than any ability in the actual field of software engineering. This has gotten to the point where some in the industry have designed multi-stage interviews that last for weeks. Some of these interviews are more useful to interviewees in detecting internal dysfunction within the organizations that purvey these gauntlets as a mean of hiring. I myself once left a job interview after having a project manager basically straight out say he hated his job, hated the interview process, didn't respect his boss, wanted to quit, and that the organization he worked for was completely dysfunctional. When you make your candidates run these gauntlets, you're making your employee enforce, guard, promote, and purvey this human misery. Eventually, it starts to affect them too. Jobs requirement. The job interview. Invert a binary tree on this whiteboard. The job. Make the button bigger. Everyone seems to have an opinion of that one thing that will be able to identify a developer who is going to be a solid contributor to the organization versus one that won't pull their weight or, in the worst case scenario, actually slow the team down. Throughout my career, this has led to having engineering managers perform increasingly bizarre programming challenges and methods. Everyone who has done coding interviews knows the ultimate truth about the matter. You really can't divine much in one of these standard programming interviews. Even if a developer aces the company's curated hacker rank, they could be incredibly unmotivated, slow, lacking in skills around architecture, research, debugging, deployment, reading other people's code, to just name a few, and just well primed and trained on interview challenges. I've seen incredibly talented, hardworking engineers fall apart in whiteboard interviews because the skills to reason about a brain teaser on a whiteboard happen to not exactly align with the same skills they used for years writing actual software and solving real-world problems. I have also seen developers who absolutely ace these canned interview questions turn out to be lazy, unmotivated, unable to work on real world problems, and ultimately incompetent. I would say the rate of finding a good engineer versus a bad one based on traditional interview techniques has been no better than a coin flip, and I would wager the plurality of technical interviewers would tell you the same thing. I would say, given the sheer amount of money and time being spent on this, it's a pretty sad state of affairs. The truth is, doing the job itself is the only thing that actually proves whether your hiring intuition was correct or not. There is obviously an issue with hiring improper people to your company. There is a cost to that. Hey, everybody. Hey, Chris. Hey, Raiders. Welcome in. Good to see you guys. I'm just going over, okay, here, I'll give a brief overview. Hey, IT, thanks for the follow just now. Normally I'm writing a game, in C, in vanilla C, compiled to WebAssembly, running on the browser, with vanilla JavaScript and, CSS and, just using div elements. There's no web GPL, no web GPU, no hardware acceleration. That's normally what I'm doing, right? And then I do cool stuff like this, where I have 3D, CSS 3D, pure CSS 3D. That's normally what this stream is about, okay? Normally. Once in a while, I go off on a tangent and I review scientific papers. That's what even though I don't have it up on screen right now, I was doing it at the beginning of the stream. Sorry. We went over this article which is from Ryan Fleury, essentially describing the idea that programmers cost themselves time, and because they think that by replacing CPU efficiency for programmer efficiency, there's a net benefit. There is not. So we went over that, and then we proceeded to dig into that a little bit. We read a paper about how video games are getting worse, not better. Literally a study on what kind of bugs exist in video games, and how like things like the libraries, frameworks, and languages being used cause problems with video game bugs. So we literally read this whole paper, all the numbers, all the statistics. It was based on 2020 numbers from Steam, what kind of bugs are reported, how often, why, crashes being the biggest thing, etc. We went over this paper, over how maintainable is like clever code, code that obfuscates or abstracts in favor of making the developer deal with simpler code. Does it actually make things more maintainable? Python was a great study case for this, because you could look at Python because it has a bunch of these libraries that feel like simple. It's kind of like its ethos. Does it make it more maintainable? The answer might shock you. We went over TypeScript. You would think that TypeScript would reduce bugs. It would reduce the ability to fix bugs, how long it takes to fix bugs, etc. No, quite the opposite. TypeScript actually makes things worse as compared to vanilla JavaScript. And they went over hundreds of projects between JavaScript and TypeScript, 16 million lines of code. It's not a small study. We are now going over the idea that the Merca needs to open the visa program because there are not enough talented programmers. The entire premise of my stream is the reason why I'm building this game is to show that we're actually not encouraging programmers to understand fundamentals. We're encouraging programmers to stay within their paradigms of language, library, or framework, and not to seek anything out beyond that, because don't worry about it. It's too intimidating and too complex for your tiny little brain to understand how to work with vanilla CSS. Use Tailwind. You don't know how to work with vanilla JS. Use TypeScript and React. You don't know how to do this or that. Just meet these check boxes and you're going to be fine. That's essentially what we're telling programmers. You're too stupid. We're smarter than you. Do these things, etc. And so we're not only are we dealing with programmers and not really giving them the right incentives to actually understand what's going on under the hood, but we're also not gauging for whether they are good enough to begin with. We don't even know the kind of talent we have because we're not even doing recruitment, for example, in the correct way. And so this is the article that I'm reading that goes towards that. And yes, Chris, I saw your tweet earlier. It is a poor take. Sorry to say, but you don't save a couple of bytes because you're a lazy programmer. If you were in the 70s or 80s and you needed to save a couple of bytes, you were doing it because there was a resource limitation, not because you were lazy. And a couple of bytes is a couple of bytes until it's a couple of bytes times 10 million people using it. Then it's 10 million bytes. Or if it's 10 million bytes inside of your hardware, a couple of bytes turns into 10 million bytes. Those couple of bytes go a long way. So the idea that programmers have always been lazy and therefore they are lazy now, no, you are incorrect, Chris. I'm sorry, you are dead wrong. Programmers needed to do that couple of bytes save because of hardware limitations. Today, we don't have those limitations. You're 100% correct about that. That means that programmers do not have to be lazy, but instead, we have become more lazy as hardware has become better. And yes, I agree with you here too. We are still incentivized to be lazy. That's exactly right. And I think you and I agree more than we disagree. The entire premise of the tech industry is it's good enough. That's what everything is. Anytime you ask somebody how are things, that's why I go over these studies. And I have live streams that you can go back from only a few months ago. I'll put them in a proper list. But I've gone over these studies over and over and over and over again. And it's exactly to this point, right? That we don't even know the talent we have because we're not encouraging programmers to um to to kind of like expand on that talent. We're encouraging programmers to be lazy. We're just saying, hey, we got it solved for you. Don't worry about it. Don't worry about it. It's like a cult, honestly. I was like I say this all the time. So for anybody new, I'm an ex-Jehovah's Witness. I used to be in a cult. And what cults like to do is they like to make it so that you don't ask questions. They have the answers. Hey, is being a Christian hard? Is understanding the Bible hard? We got you, bro. We have a few men who have a direct line to God. And these men translate the Bible for you. And they're going to tell you what the Bible says. And if you follow these steps, you are now saved by God. You're going to make it. It's exactly the same thing, but just in tech form. So we actually don't even know the amount of brain power that is available. I don't actually think a lot of our developers are stupid, unlike what Elon and Vivek insinuate by saying, well, we don't have enough talent, we have to open up our visa program. I don't think that's true. I think we have a lot of smart people, but we're not incentivizing them to be smart. VC funding is always incentivizing for the quick exit. The amount of money that people put into, say, video games, right? Video games are massive. They're like, what huge massive leap forward have video games taken as compared to the huge massive leap forwards in hardware? Barely any. But people still throw their money at video games. The incentives are not there. And yet what I think somebody has to break that cycle, right? Somebody has to break that chain of bad incentivization. And I think it has to come from us, because the programmers have proven before that when they speak up and say, hey, things are shitty, let's break the shit, then things change. We've done that before in the past, and I think we need to do that again. The Discord, if you want to join the Discord, here, IT. And then we can always, we can chat. Delivering value is what we're paid for. Yes, delivering value. But this is the other problem, is that you're right, Chris, there is something beyond just what we can do. So who determines who determines why we're getting paid, right? What is the value behind what we're getting paid? We don't have all the power in our hands to say, well, the business value is this, right? But if you are someone who wants to make money as a business owner, then you can make the case that a more performant, more efficient, leaner piece of software will make more money in the long run for a business than slop code generated by just whatever you pump out in AI or some library where all you know is that library. You don't really know what you're doing in the end, things like that. Do you maintain your own car? When was the last time you replaced your own spark plugs? First of all, that's not an equivalent. It's not okay. You know what? Let me grant it to you. Let's say it's fully equivalent comparison. The difference would be that mechanics, when you go into a mechanic class, like you go to become a mechanic, there is nobody who tells you that you do not need to pop the hood to change the spark plugs. Something will change the spark plugs for you. That's why I think it's a non-equivalent comparison. We don't have the same thing. We build our own tools and we tell people to use those tools. So yes, there is actually an incentive for you to do that. The user of the thing is not who I'm talking about when I say programmers need to be incentivized to do better. So I don't see how that comparison jives at all. High demand and skill scarcity? Maybe, perhaps. And not the only thing a user experience is about and with the product. Yeah, okay, so, but I have been through, Reggie, I have actually been through study after study after study where definitively millions of dollars are lost by websites and software that do not perform within milliseconds. because the nature of the way it was built made it so that it could not perform within milliseconds. So I don't think it's self-aggrandizing. I think it's reality. The market speaks for it. As a dev, you're incentivizing people to be better, but you haven't even optimized the car you drive. In order to optimize the car you drive, people have to be better. I mean, is this like a chicken and egg thing? Is the conversation primarily rooted in performance? I mean, I'm all for performance, but it seems like move fast as the player. You're referring to caching things like McMaster, optimizing images, performance, straight up performance. I think what's happened, I am taking the position, the extremely far position, that moving fast has created moving fast and only focusing on business value. Ship it, business value, and that's it. Doesn't matter how good it is, doesn't matter how fast it is, doesn't matter how performant it is, doesn't matter how much RAM it takes, doesn't matter how much hard drive space it takes, doesn't matter if video game DLCs take 600 gigabytes, doesn't matter if it takes 700,000 seconds for a page to load, doesn't matter if what is supposedly one of the best front-end frameworks in the world does stupid shit like this forever and ever and ever and ever. Does not matter. Ship it, business value. Ship it, business value. Ship it, business value. That's all it is. That is complete bullshit. And we have pointed ourselves into such a corner where we think that this shit is okay. And then we just go circle jerk each other and go, yeah, good job, man. Good job. Isn't it nice that we all got that exit round of VC funding? Isn't it nice we all get that sweet paycheck? Isn't it nice that we delivered that business value? Yeah, it is. But at what cost? And there are actual real costs to this. For example, as a result of some bullshit like this, you probably have to import a bunch of libraries. I have been over this. I'm not going to go over the details. You can just go check it. It's free and live on my YouTube lives. The libraries you import, how many security vulnerabilities are you importing? Do you know how many there are? Do you know what the cost of that is? When you're importing bullshit? Damn it, I can never get this stupid thing right. What is this? What is this bullshit? And that has real world impact because all the complexity and abstractions that we bring onto the table in order to make things easier and nicer for us at the cost of performance have a real world impact. I have been over actual like scientific academic papers that scientifically study security issues that have come up and why they have come up. These kinds of security vulnerabilities come up because people can't even begin to fathom checking all the different complexity levels that they have to check that instantiate the entry points for these vulnerabilities to begin with. And then what you have is things like the entire east coast of the United States not being able to receive gasoline because trucks can't run, operating systems in entire states, operating rooms in hospitals not being able to run because their power gets shut off, 911 operations in entire states being shut down. The cost of cybersecurity, not the cost of like having people in cybersecurity, the consequence cost of cybersecurity is the third largest economy in the world. It cannot even be quantified. It's a guesstimate at how big it is, and it is guesstimated at $9 trillion. That does not include the cost of life. It is next to the US and China only. And it is because of bullshit like this where we go, well, what else are we going to do? We have to make that paycheck, right? Let's just not complain about anything. It's good enough. It's good enough. No, it's not good enough. It impacts me, my family, and you and your family. And somebody has to say this because otherwise nobody's going to care. No one's going to give a shit. Everybody is very happy with the status quo. That includes executives and business people who need to be incentivized to care about this more. So fine, I'm going to sit here and I'm going to talk about it and hopefully get people to at least consider the idea. No, we don't have to go back to writing assembly, but can we at least consider the idea that we should be at least trying to do better? And can we at least consider the idea that probably maybe we're not even close to using the talent that we could be using currently in the tech industry? I think incentives are misaligned there. Engineers are incentivized to be good enough to get hard paid, and employers are incentivized to make a product that's good enough. Nowadays, solid hardware gives us a handicap too. Incentives are misaligned. Yes. But we can talk, like, imagine if programmers talked about that. Imagine if programmers could actually articulate, right? Imagine if a programmer could, if more programmers than we have today could articulate the idea to an executive, hey, do you want to make like a little bit more money? Look, for this much cost, we can build something that's a lot more solid in this way. Yes, there is an upfront cost, but what ends up coming out of it are fewer bugs, better performance, better user satisfaction. Maybe we outpace a competitor, things like that. Imagine if programmers had more fundamental awareness of how to articulate that. I think even that would be enough for me. I'd be like, great, that's great. Then we're in a much better place, because then programmers could understand that when they need to make that case, they can make that case. Right now, I don't think that's the case. Right now, programmers are just come on board. Hey, do you know React? Good enough. That's all you need to know. Stop using PHP, stop using WASM, stop using web, stop using JS, stop using x86, stop using Unix shells, stop using Mac OS, yada, yada. Just start smoke signaling, right? I don't think it's a far position. Focusing on shipping and money is always going to take precedence. I don't think anyone thinks you're wrong. At the same time, people will assert that people have more RAM and processing power than ever before. But at the same time, it's an upward spiral cost for sure, no doubt. It feels like both sides have valid points. Security is a very strong point, though. So I actually think that it leans more towards, my point leans more towards the business as a counter to the business side. Shipping and money is always going to take precedence. Again, what if you could articulate and prove that having less security vulnerabilities, having a tighter, a more performant system, have something that like performs well, it's easier to reason about, less abstractions, faster to build, less layers to it, things like this. These things necessarily lead to more income over the long term, maybe not in the short term, but over the long term, because you have a solid product that you can count on for far longer. If you can articulate that properly, an executive or a business decision person is going to be like, should look at that and go, oh, more money for me. And most of the programmers in my company are telling me that this is a good way to do it. Okay, well, let's find a way to make that happen, right? Right now, these conversations aren't even beginning to take place. They're dead on arrival, because when somebody enters into the company, they start with, I have a paradigm. It's React, it's Rust, it's whatever it is. And all I know is this abstraction. I don't know anything that happens underneath, or I know very little about what happens underneath, nor am I incentivized to know what happens underneath. Okay. So I was just going over the hiring practices, because I think the hiring practices are also crazy. Like, I was showing this, a very simple question: print each level of a tree on a separate line. 90% of computer science grad students can't do it. You take the binary tree, you print out 1, 2, 3, 4, 5, 6, and that is supposed to give you some kind of indication as to whether someone is good or not. If you can't instantly solve it in your head, you have some studying to do. No, this is complete and utter bullshit. All this is a way for somebody to determine whether you have, let's see if I can find it, whether you have academic chops. So this person hired someone doing exactly like kind of this thing. He was extremely academically savvy. He was not savvy with the act of building software. Why? The first signs of trouble came when he had issues just checking out our code base. He then spent a week tailoring his IDE and development tools before he could start working on the project. As a fan of highly tailored Vim and shell configuration environments, I chalked this up to quirky perfectionism. The real revelation came when I went to pair program with him on his first story, a fairly basic time zone problem. This is when I noticed it seemed to take ages for him to type out a single line of code. He would seemingly get lost navigating around the project and was confounded by reading other people's code. And that's why I read this article at the beginning, because it exactly outlines exactly this, where you have a programmer who builds something like Ryan builds a debugging tool, and then you have a second programmer who is writing a piece of software that ties into that debugging tool, and they have an interdependent chain requiring each other's tool. Anytime you add a level of abstraction or a build step or anything that costs CPU efficiency in favor for programmer efficiency, I feel good doing this. Doesn't it feel good to do this and not have to worry about like this or that, etc.? What you're doing is you're adding time on top of that interdependency chain where people have to wait on each other for things to happen. And you just cyclically do that until you have the NPM install version of holy shit, everybody now has to interdependently import everybody's programming problems, everybody's security vulnerabilities, everybody's slow build steps, etc. Right? This is exactly the kind of problem. You can't get the solution to whether a programmer can function in this way. It's already in a bad, like it already starts off in a bad place because of things like this. And then you get this. And you think that this is going to solve that, you're going to be able to figure out whether a programmer can fit within that paradigm by giving them problems like this. Maybe in some jobs, you might actually literally do something like this, just in a little bit of a different way. Sure, okay. But that's exactly why I'm reading the article here. By the way, thanks, Chris. If there's a mod who hasn't given Chris a shout out, please make sure to do that. And thank you for all the follows. Canny, Forward Gator, Kevin Naughton, thank you. I appreciate it. Kevin, I think I recognize your name, by the way, man. So like the whole premise of thank you for the shout out. The whole premise of like that you can do it this way, I just don't think works. Thank you, Battle Gnome, for the follow as well. So reading the article, where is it here? It was just going through like someone who did actually do the hiring process this way. And what I'm trying to highlight from doing the hiring, from looking at the hiring process at this level, is that we don't even actually have a good way of determining the type of skills that we have in the tech industry to begin with. And so when someone like, and here's why I think what Elon and Vivek said in terms of the H-1B visa stuff rubbed a lot of programmers the wrong way. When they said, we do not have enough skilled talent, a lot of programmers went, what the hell, man? I'm right here. Why? Because I think that all of these abstractions, like these abstractions and other things that we're doing, you know, other languages like Rust or things like that, where you get hand-holded and you're told basically by cult leaders or cult-like leaders, hey, all you have to do is this and you're going to be fine. You don't need to ask any questions. You're going to be fine. It's essentially everyone feels like they're being talked down to. Everybody's feeling without... I don't think you realize it, but you're being told you're stupid without being told you're stupid. You're too stupid to it's too intimidating to handle CSS. You got to use Tailwind. Otherwise, you can't do it. It's way too complicated. You can't do vanilla JavaScript. What the hell are you talking about? You do vanilla JavaScript? No shot. No shot. And so it makes you feel stupid. And so you're used to hearing that you're stupid for what has been years now. And then Elon and Vivek come along and they're like, yeah, guess what? You're not just stupid. You're all so stupid. We can't find anybody in North America to, fulfill the kind of talent we need. We're going to go look abroad because there's more talented people abroad. And so, yeah, of course, a few feathers are going to be ruffled. But I don't think that's true at all. I think the problem is we don't even know the talent we have. We don't know how to nurture them properly. We don't know how to identify them properly. And we're certainly not setting ourselves up for them to find ways to get to the point where they can appropriately use the talents they have. We just confine them and box them in to bullshit like this right from the word go. And that's what I'm trying to bring attention to with all these articles, with the scientific articles, the academic articles. That's what I'm trying to bring attention to when I'm building a game in the most hardcore mode I can think of. You can do a lot with very little. I am a high school dropout. My highest degree is grade 11. I lived on the streets. And I can do this. All vanilla. I don't need C standard library. I can write it myself. I don't need to use any framework. I can write all my vanilla JavaScript here. I don't need to figure out, have a bunch of glue code and build steps and things for me to handle things for me. I can push myself enough. I have the brain power to go and figure these things out for myself. Does that mean you have to do what I do? Nope. Does it mean that you could understand more than you think? Yes, because there is no way on the face of the planet that however many people there are watching, I don't even know right now, that I am smarter than most of you. There's no way that's true. Stop accepting the idea that you're dumb. You're not. We can do more. And that's the message that I want to be essentially saying. And it has downwind consequences. When people care more about what they're doing, when they understand more about what they're doing, you can fix the tools that are broken or things that aren't as, running as well, as Chris would say, right? So like this. Where is it? Like this. Like this. And the data's there. I know what you're thinking. Maybe the data's not there. Oh no, the data's there. It's just that people are not happy with what they have. And a vast majority of these comments are not happy. You have to get people to care more, and then they can speak up to that executive and say, hey, we can make more money doing this. It's not as hard as you might think. We actually have the capability to deal with this. It's going to be better for everyone, yada, yada, yada. We don't even know how to have these conversations. Hang on. We need another 4-hour Discord talk about vector soon. It's been a while, yeah. Performance is probably more applicable if a company is in maintenance mode since they already built something. It seems like that's where people would apply that area, primarily because of business ship and go. Consequences for security breaches and security flaws seem low when you see it happening. I think that's probably true, though. They're not thinking about web software. I've heard Comrack and others say the same thing. React again? Yeah, hey, Peg, how's it going? Musk isn't talking about web devs. He's talking about embedded engineers and AI PhDs. Right, but tech in general, they did go into the entire STEM field. That does include tech. I think it's the exact opposite. People are being told they're smart by having skill issues patched over by frameworks and safe languages. That's the problem. That is the problem. We're catering to people. We're catering to subjective preferences, which is how do you make a programmer feel good? So what happens is it's twofold really, and one is incentives, right? So I've literally been in a company where the company cannot afford to hire the right expertise to come in and do React stuff. So what do? They hire a bunch of like CS grads out of a local university because they get half of it is government funded that way. And then they only have to pay half the price. And so then the React developers come in and then everybody feels good because the React developers who have come out of that go, hey, I feel good because I can contribute as if I am like the expert over there who can ultimately do much more than I can outside of React. And then the business incentives are also aligned because they save money by having a team of React developers who can also accomplish the things outside of React that other people can do. So the entire incentive system is both a financial incentive system and a my feelings incentive system. Did someone piss him off mentioning React is better than C? No. Yeah, now Big Brother comes along and says, no, you're stupid and people can't handle it. That's right. Talent and potential talent. H1B isn't for potential talent. It's for fully qualified, hitting the ground running people. I agree with you. What was said along with that is we do not have enough talent in domestically. I agree that H1B is intended to get people to hit the ground running, but it also began with we don't have the talent domestically. And I'm arguing we don't even know that. Abstractions are most useful when you first underlying details. I'm not sure what. Okay. When it comes to performance, could you argue that there are a lot of factors that are outside of your own control? Yes. So that's why I do not. That's why I'm not actually saying. I mean, first of all, if we were all to go back to writing what assembly, what would actually be wrong with that? Like if it just became the standard again, what would actually be wrong with it? What would really, really be wrong with it? But that's not what I'm advocating for. I'm taking a far position in hopes to pull people into a more medium level position, which is that we might have some things in pure performance that are outside of our control, like particular aspects of hardware that just they are what they are. But we can at least be more educated about it. There is a long history. Yeah, battle. Yeah, I know. The stream is the rant. That's right. If Google or Meta had a convo on performance optimization for every project they undertake, wouldn't they say it costs more to focus on performance than it would be to go the other route? That's what they would say, because, and that's what all the developers around them would also say. That's right. And that's exactly my point. I don't think that's actually true. I think if more projects at least took a more educated guess or a more educated approach, why the opposite direction might not be as costly as they think and might bring in more financial reward, you would have to have programmers who could actually speak to that to some degree. And then you could have proper conversations about it. I don't even think we're having proper conversations about it. This is like putting a scope in a rifle before you master marksmanship fundamentals. Yeah. Programmers are lazy these days. I mean, they are. We don't even know that we don't have the talent in the US. We do. Unfilled jobs. Why are those jobs unfilled? Why are those jobs unfilled? Partially because of hiring practices, partially because of phantom jobs, and partially because the H-1B visa program is being gamed to begin with, where you have to have a job which you list, you don't really go through all the proper motions to fill the job, and then you hire externally. Yeah, my rage was not anti-Musk, no. I actually do agree with Musk that overall, opening up the visa program so we have more talent is actually a good thing. I'm not actually against that. It's the beginning portion. We don't have enough good talent domestically, therefore. Ghost jobs are a problem, yeah. Because there aren't enough people. As someone who's been hiring system stuff for here, it's hard to find ground ready talent. That's also true, Raggy. And you can think about the cyclical nature of exactly what I'm describing. Why do we not have enough people? Because enough people are not being trained in the right things. Why do we not have enough people? Because not enough people are being trained in the right things, and so on and so forth, right? And then you have all these other confounding factors. Says the Canadian. Shut up, Lem. You're yearly reminded that FANG companies hired graduates to do BS work and basically sabotage their ability to gain experience. Yeah. Companies fluffing Department of Labor data and fluffing their own data via stocks and appearing in a certain way is a problem for sure. Yeah. Yeah. There are other factors, right? It's easy to find juniors, but you need senior as well. Ghost jobs are huge. Yeah. H-1Bs coming in as seniors train juniors. I mean, right. But what are we training them on? If the underlying principles, I agree with what you're saying, Raggy. If you can have H-1Bs, seniors coming in, training juniors, that's a good thing. Yes. That's fantastic, because it means that there are smart people training less experienced people, right? How about this? Maybe let's not use the word smart because it might not be very accurate. More experienced people will train less experienced people. That's a good thing. But what are they training them on? Because to me, all it sounds like is we're just going to have more experienced people in React training less experienced people in React. We're not actually changing the thing, the underlying thing that causes the problem to begin with. The real problem is there's too much software. Yeah, Lem. Yeah, too much software. So, like I can fully appreciate that my rants and stuff are, unhinged, and I'm advocating for something that seems not very doable, maybe not insurmountable, but it's like, geez, what are you going to do? Just like change the entire ecosystem of the tech industry? And like, I get that. I understand that, but it has to start somewhere. And I'm trying my best to defend that far position the best way that I can with the most data that I can possibly grab, the most, logical arguments that I can possibly think of, and also by putting my money where my mouth is and on stream doing the thing I'm advocating for to demonstrate that Mr. High School Dropout can do a lot with very little, which means that a lot of you can also do the same thing. I'm not doing web subs, so I don't have the problem you're talking about. Yeah, outside of web, it gets less problematic. Companies are not willing to pay for top talent. Some are not. Yeah, most are not, I guess. I've worked with React focus folks in my company, helping them to do more work, reach lower down the stack they're using. So I would say, Raggy, then it sounds like because you're not doing web stuff, you automatically have an advantage. Web is the worst offender. It is the path to least resistance to idiotic, moronic paradigms, because it's the easiest place to introduce whatever bullshit you want and just have it gulped up by everyone. So outside of web, it's a lot harder to do that. Although I would say that the same type of mentality and thinking is beginning to infiltrate outside of web into backend, into embedded, things like that. Not very much, very little, but still. H1Bs about getting top talent at a lower price. I believe that Elon literally said, we do not have enough talent domestically. I'm pretty sure. I'd have to find it. I'm going to have to find it. But I'm pretty sure he said, we do not have enough qualified domestic talent. US software salaries are massively inflated. It's true some H1Bs are cheaper. Yeah. There's a whole lot of entry-level devs who would gladly work for pennies. Yeah. Yeah. So that's kind of like that article. Yeah, so that's pretty much the stream. I was kind of getting to the end of that, so it was good timing. And just kind of talking about these. What did developers say about technical interviews? Oh, yeah, that's right. I wanted to read this one. It's not like some kind of like a gotcha data set, but concerns, relevance. Building a great and useful app rarely requires Herculean feats of logic and puzzle solving. The number of times I've seen things like dynamic programming come up in a real world application are vanishingly small. I'm a data scientist, and Google asked me to sum all values of nodes at each height of a tree. I had to implement the tree, buffs, and the algo, which was easy once you have buffs in 25 minutes, minus any talking time. Buffs is not something I thought about much in the last 5 years, and quite frankly, could care less about. I got stuck when I knew I needed something to finish implementing buffs, but couldn't remember, and the Google interviewer offered no help. And then you wonder why the resulting, sentiment behind, after that is there's not enough qualified developers, right? Let's keep going. HN elaborates. This then becomes representative of your experience in spite of the fact that you are never likely to be confronted with that kind of problem with that kind of time frame. Whatever is in your CV and whatever you can say about what you've learned over the years becomes totally irrelevant in the face of that. It's literally like the ultimate, you're a fucking idiot, slap to the face hiring practice. Hey, can you not invert a binary tree? Well, then it doesn't matter how much experience you have. Get fucked. Get the fuck out of here. And by the way, Elon, we don't have enough experienced people here. It's so dumb. I wrote a custom hash map for Java, used buffs and dubs on graphs, wrote a top-down custom parser, custom string searching algorithms to solve real business problems. I would rather work with someone who knows how neural networks really work rather than someone who knows how PyTorch or Keras, because they can be learned rather easily. And some industries, knowledge of algorithms can be more valuable than knowing a myriad of frameworks that change every few years anyways. Hey, here's one I can actually agree with pretty much in full. Pretty much in full. There are career stages for candidates just out of school with a little experience. Asking algorithmic questions totally makes sense. For some senior candidates who actually progress to the next stage, not just spend a lot of years, the questions become more real life, more open-ended, and with more than one or sometimes none correct answer. There is anxiety, and this is why I advocate for the way that I would like to see hiring practices done in whole, which takes the anxiety out of it, which lets the developer just talk about something they're passionate about. And you just ask probing questions about something they know deeply. You can get a lot about that rather than just asking gotcha questions, making them feel stressed, because even a very smart and well-rounded developer can get stuck on a question where their brain just like stalls out. Effect. I think it's offensive, and I don't like how the industry has standardized on basically assuming everyone's a bullshitter. I mean, a lot of people are a bullshitter though, honestly. What's worse is that you'll have to repeat this over and over again for any company you interview with. Some candidates see themselves as being a gladiator fighting in the Coliseum for entertainment, but made up puzzles for which the asker already knows the answers, so they sit back and watch us dance. Yeah, it's a degrading thing on top of like, hey, did you have to like, be a sheep? And do some stupid puzzle that doesn't mean anything. And then once you made it through that, because you're an idiot, we thought you were an idiot. Well, maybe you're not so much of an idiot, but you know what? Use like React or Svelte or Vue or something. And you don't have to understand how to use anything under the hood. It doesn't matter what vanilla JavaScript is doing. Who the hell cares? You have this entire ecosystem because, hey, you're still an idiot. You're just being called an idiot. The entire chain. Why do you think people have imposter syndrome? I have come to believe it is a part of an industry-wide negging style to keep people in their place. It is like some companies like to feel special after being invited twice for Google interviews. I mean, really invited by their HR, not me applying for them. On both occasions, I failed the process with their stupid questions. I started replying to their HR. If I'm so good to be invited, but in their eyes, unable to devise an inode search algorithm for unlimited hard disk sizes with a specific set of hardware and search time constraints over the phone interview, then why can't you just please stop inviting me? And maybe just stop accepting the invitation? I was literally asked, what is the time complexity of the moving window average algorithm over an array? And when I asked for clarification, I could hear an edge of, I guess, frustration in my interviewer's voice. Granted, by this time, we'd been through a couple of other problems, and time was running short, but I still think it was pretty unprofessional of the interviewer to let frustration or any other sort of negative emotion show during the interview. There's definitely some gatekeeping there. I don't think that's like a valid argument for what I'm trying to make, but there's definitely some of it there. The thing I found strange is that some interviewers would walk in the room, throw up a coding exercise without any intro at all. They literally wouldn't give their names and what projects they worked on. However, some candidates also have had happy experiences. Oh, really? Let's hear about these happy experiences. I've interviewed for Google and Apple internships, and the process has been extremely pleasant, with the interviewers happy to give their time. Meh. With Apple, I got to meet the entire team and spend time with them. Meh. I've heard similar stories about the Microsoft interview process. I mean, they even fly you out to Redmond. Meh. Affordances. Expecting perfectly correct code on a whiteboard seems to be a slight abuse of the medium. Whiteboards and chalkboards specifically exist to sketch things out in an ad hoc fashion, often in a collaborative and easy to edit way. Every time a developer has told me something like this, they then nitpick syntax and appear to be primarily concerned with, does my whiteboard compile sorts of problems? Or how about when you actually do the actual project, and then what they end up doing is the job opening wasn't even real to begin with, or they just don't like you for some reason. You know, maybe you're better than them, and so they come up with some weird syntax issue to be like, nah, you aren't good enough, right? And so they reject you. I've had the experience during a technical phone screen with a different hires only the best company. I was asked to write over the phone a trivial statistical algorithm and started to describe the algo. Function f returns a double and has two params, pointer to the start of the double array p, and integer n for the length of the array. Apparently, on the other end of the line was a human compiler that kept rejecting my input and preferred double f open parens double star p comma int close parens. What the hell is this? Like, so like we don't even know how to gauge whether someone is a good programmer or not, let alone what to do with them once they've made it. Right? These are all very like uh pertinent criticisms of the hiring practices. And it's no wonder that people can't find jobs. First of all, people can't hire for them. And second of all, people can't pass this shit. Tell me what the Newtonian particles in quaternion space and four-dimensional time travel do, and then maybe we'll consider you to like move pixels around on our front end. It makes no sense. Um, Gatekeeping is a fun conversation. Could care less. SpaceX has 97 open positions. Looks like almost none are front end. Yeah. Um, yeah. Hey, I'm Speedy. Yeah, Sci-Hub is great. Fake jobs are a big issue here. Yeah. But hello, my name is Eval. Fake jobs are a technical workaround so they can import cheap labor. Yeah, that's what they do. So literally what they'll do is, I've seen this happen. They'll create a job opening. They will put it into a dinky little local newspaper. When they are asked if they attempted to find someone locally for the job, they'll say, yep, we put it in a newspaper. Cool, you're good. And then when they cannot fill the job, then they get whatever they need to get in order to import cheap labor. And I didn't even get into today. I'm going to save this. Are users actually happy with AI? AI systems like chatbots that are supposed to kind of like walk a user through a series of steps. An actual academic study. We already know we already know programmers aren't happy. Right? We know that. They're self-IDing as not happy. Right? Are users happy? With all the new advances in AI, I don't even know where I went now. Here. I'll give you a guess. I'll give you just one guess. And then, not just that. I had one lined up. Exactly to this point, because you are all talking about, oh, but the business value though, but business incentives though. Does code quality have an impact on business? Oh, the answer might shock you. And then I had one for, we went over why TypeScript doesn't do anything. It doesn't help you at all. In fact, it makes things worse. Where's the other one? Oh yeah, and then this. Your beautiful machine learning systems, which are made to, help you autocomplete and work your way through problems. What are they actually producing? What are they trained on? So there you go. I win, you all lose. Game players are the most unhappiest, yeah. Are drained on garbage and vomit in that order. Yep, exactly. So, just to kind of close things off, because I went through everything that I wanted to. I'm going to save these for another time. Something that I built the other day. This is something that I don't think is talked about when we have these conversations. We have desensitized users to just accepting that things crash and they're slow and they suck. So when it comes time for users to report something, they just don't care. We've desensitized them. And even if they could report something, they wouldn't even know how to talk about it. So I built a website where users can submit their problems that they have experiencing anything, whether it's on the web, on desktop, on mobile, it doesn't matter. Your kitchen fridge, it doesn't matter. And then what I do is I take the submission and privately review it and provide a technical background as to why and try and figure out how we can get attention to it. And what I'm hoping that I can demonstrate by doing this is that there are a lot more people who would complain and not give you their money if they knew how to talk about it in the first place from the consumer perspective, which I hope will open some eyes from the business perspective. Look at the money you're leaving on the table. Users are just doing whatever they're doing. They don't know how, if they could actually like talk about it, you might be shocked at what they would tell you. And having some technical backing behind that. So that's why I built explainmybug.com. And then if you want to, you can catch me talking to Eric Weinstein. I was on one of his X Spaces talking about exactly this. And he wanted to talk about STEM in general, but he ended up agreeing with me. He ended up saying pretty much everything I was saying, just in different words. Well, actually, not even that. So if you go on his X profile, it's the last 2 spaces he did. I was on there. Yeah. And then I still have to do this enlightened programming stuff. All these articles are for this website where I take all these videos and then I post them here and I create a written version of them. So I still have to work on that. But previous rants are on my YouTube history. What's up, Yazzies? So that's it. That's all I got. That's my rant. I'll hang out for a few more minutes and then I'll call it. The rant has ended. Yeah. Yes, it's true. I do. Raggy, I do need a new job. You're absolutely right. If the rant is actually eternal, it lives rent free in your head. Once I end the stream, you're going to be hearing me rant in your head. How's everyone doing? How was Chris's stream? You guys had fun? Any of you regret jumping on the rant? Ross, you just woke up? Then your opinion doesn't matter yet. You have to have at least 1 cup of coffee. When's the next rant? I have a bunch more articles lined up. I still have to find a few. There are a few topics. I try and make the topics kind of like related to each other. So probably not until the new year. We'll see how quickly I can pull it together. Finding these articles and reading them and then piecing together like a structure for them, it takes weeks. It's not easy. Yeah, Pure is only here for the rants. Yeah. Hey, Land, how's it going? Okay. um. Yeah, pure. You're VIP. There's usually multiple mini rants on the regular dev streams. That's true too. Whenever I'm working on the game, which that's what I'm gonna do next time I'm on stream. I don't know when that is. Um, a rant usually comes up because usually some hotshot without any context of what we've been doing with this game comes in and starts telling me how to do all my vanilla stuff as if he knows everything about my project. And then I go on a rant. You just time out. You know what? Just because I did such a good rant, okay? You're all getting 3 minutes of ads so I can make my sweet money. Here we go. 3 minutes of sub to me or suffer the ads. I want my Bezos money. And be sure to subscribe. And while you're at it, check out my YouTube. Hit that like button and that notification bell while you're watching Twitch ads. You only got 5 seconds of ads? What the hell? What the hell? Is Bezos screwing me out of ads? If you want to see more hot rants, sub. It's going to take at least 10 more subscriptions. Run it again. Just run another 3 minutes. It won't let me. Yeah, Bezos thought about it, right? You run the 3 minutes once, and then you have to have a cooldown period. It's like you turn on a buff, and then you got to wait for the cooldown before you can turn the buff on again. There's still a minute 47. We're doing the whole ads. I want my sweet ad money. Anybody else watching on like X or something is like, what the hell? Why would you do this to me? Yeah, see, it won't let me run it again. You should open your stream on stream to show them the ads too. just to the quadruple ad them. I think actually that would work against me. I want people to watch the ads. No, maybe it would be okay. You only get Norwegian ads. Usually they're short. Did you just cell phone about the state of your country? Bro. This isn't about money. It's about sending a message. That's right. And I need money to send that message. $30 seconds. In the meantime, I'll find someone to raid on the Twitch side. I don't know when I'm going to be back on. I'm sure my wife has probably figured it out already. I'm sure if I ask her, she'll tell me when I'm going to be back on, but I don't know when I'm going to be back on. To my shame, I do have some C++ and vanilla JS script CSS 3 chops. I must return to my roots. Yeah, you should. Look, if I can do it and I can build, a video game doing that, there's no reason why you can't either. Like no reason at all. Let's see who's doing what here. Yeah, join the Discord. Join the Discord. You can talk to me on Discord. I'm around all the time when I'm not streaming. I'm building GigaChad vanilla software. Stuff you could only dream of. Do not join the Arvis. That's not Arvis. That's not what I pay you for, man. It would be great. It would be so funny if I sent you guys to a chatbot stream just to like really rub it in, you know? That would just be the icing on the cake. A web app that creates web apps. Ooh. Ooh. Um oh, hey, Ryan Fleury's on. Oh, we have to raid Ryan. 100%. 100%. Okay, we're gonna raid Ryan now that my sweet ad money is there. We're gonna raid Ryan. Say hi to Ryan. Tell him. I'll tell him that we read his article today on my stream. He'll like that. Yeah. Thanks everyone. Thanks for hanging out. I'll see you next time. Hopefully soon. And take care. And go learn some fundamentals. Go spread the message. My sheep. My followers. Bye.